Alright, so gonna gonna end up ultimately hearing me as I take a shower. So, full warning ahead of time. Alright. Might shave. I'm not sure yet. So there's that. I want to go over the creative ideas and process. I was talking after I already uploaded everything. Trying to annoy me, either family or the Andrea that happens to be my SSI, case manager, which I never talked to, which would be great if I could talk to them, but good luck getting a hold of people. And then, or someone else. Usually the thing that flashes in my head is family or someone else, as I'm not aware of who they are or whatever that is. They want to learn, and then there's dicks involved. You get the picture. It's the creative process. Alright. So it's like, we're looking at Johnny Q90, the small V8. They asked me, what would you do to the engine to make it run the way you would like? Alright. So I had to go through a whole bunch of saying what that would be. So like, first and foremost, I'm ripping off that intake manifold, and carburetors, no, electronic fuel injection is what it's about. An intake manifold area, plenum, whatever that is, that's just going to be a single vacuum walled, aluminum sheet. So get the tube, big tube, cut holes, make a big funnel into small funnel like Velocity, fuel rail, both sides, standard stuff, port a little bit, and this is where it got a little trickier, okay? Shut the door there. I'm a dog. Alright. Scratches at the door, of course. Anyways. So, standard stuff works already, it's better. The carburetors on there are gas, chainsaw carburetors apparently, and they're not very good. So straight up, just don't want it. There's a super turbo. So a supercharger, that's a turbo. I was like, wait, before you go, stop. We have a generator setup with a clutch. In this instance, it's a large, so it's going to start off large because of there's spring tension here with the clutch. Alright, and so it's going to be pulled in such a way that it's at its largest. Alright, but when it spins, it's going to go and shrink, so it'll go from a large to a small. Alright, gear ratio. That's attached to the compressor. Why would you do that? That makes sense, it's more efficient though. You get a more consistent PSI for the supercharger, that kind of thing. That's exactly what it's for. The clutch, however, then once it goes to its smallest point, disengages. Put a stator on it. So scooters have this thing called a stator, which is fancy speak apparently for alternator, which is even more fancy speak for it's a electric generator. I don't know what this is about people needing special names for everything, it seems like, but okay. And then it's I dropped some things as I moved the bucket and mop because it's the only place I can put it. Shower. Because I brush my teeth in the shower. It's the cool person thing to do. If you have trouble brushing your teeth, brush your teeth in the shower. You might find it's easier. You're there anyways. Why not? So, moving on. Alright. Not done yet. It's it's going to be ram here. Is that what it's a supercharger part? Because that has the clutch. Well, there's a turbo, right? It's a turbine. This is a different turbine. We don't want that turbine, exhaust area. That's a in and one side, and it's not the right kind of design. We have to do all four, both sides, into one, 8 into 1. We want that, okay? We need them to be equaling two headers, and we need them to have their own style, in this instance, a manifold gas pressure spring. So when one moves, it then pulses, it'll push past it, but we don't want it to do it in a way where it's like actually that difficult. Okay? So a good way to understand this is it produces a vacuum, so it's already pushed out. And so it'll go through, it'll go really fast, race through, there's enough pressure that's preventing it, and then when the exhaust closes, it'll go back. Because there's a vacuum now in the tube. Preventing that from going backwards, which is more efficient for a turbine. But this turbine is not going to be those other turbines. You can't do it with that. We need higher flow. We need more efficiency. I'm looking for 35 to 40% efficiency if we can get it. Which means longer, which means bigger. But you have to remember there's volumetric efficiency problems. Okay? Like that kind of thing. So it's like, you need it a certain size intake. It's wider, it's got to go for a certain distance, and then it has to get slightly smaller, and then elongate, and then just exhaust. So it's that's kind of what that is, right? But it's going to be longer, it's going to be bigger, but it's okay, alright? That's going to have a side thing to the hub axle. So it's like, that's an axle to the axle. You know what I mean? I think that's easier. Instead of having it stick out and from the tubes, just come in at the side. Simple stuff. Keep it in the foundations, the basics, the simple, the easy to understand. Work from there. This is why I'm talking about it as I name this creative ideas and process. You know, I began it like this. Okay? I'm supposed to go take a shower. I got time. It's fine. Now, the basics turns into, because this is the basics, this is a torque converter coupler. So it's a coupler, but it's not really a coupler. So it's like, that's from the crankshaft to the transmission. Alright? That's where a torque converter tends to go. Torque converters are a bit of a weird one. Same thing with couplers. So it can suddenly make a one-to-one, standard. Once it gets up and running, it's idled for a little bit, whatever, right? And it goes faster flow rates, and then it goes from for the fan blade that it happens to have that goes to the transmission, like that axle part that's going to be attaching to, that'll suddenly spin faster, because the faster it goes, it'll suddenly skip over, fluid dynamic, blah blah blah. It's like a bigger gear to a smaller gear. And that's what it does, okay? Simple understanding kind of stuff, I feel. That's kind of what that does usually-ish. Just, it's not quite, really, if I'm being honest. But it's a way to kind of think about it that you can probably understand from there. Alright, then there's another style of torque converter. So it's like, I'm going to store torque. Alright, so it's a given fluid mass that's going to spin, that's suddenly there. It's going to have a pretty high degree of spin, and then when the RPM drops, this springs out. Well, not really springs out. There's a couple ways to do it. Anyways, that's then also helping add to that rotational mass, like a flywheel, to the given stored torque that you will receive to your transmission. Okay, which will go eventually to your wheels and everything else. And this is brief, but it's like, if you're off the gas, you're trying to change gear, it can help you with that gear and get back into those higher RPM, act like a storage temporarily of torque. It's okay. It's not quite torque, but it kind of acts a little bit like it. There's a couple other designs, you get the picture, but they're all kind of similar to varying degrees. Okay, simple, I think hopefully you can get in terms of grasp in the design. Alright, now this turbine, it's a version of a clutch with a coupler. So it's a torque converter, but it's not. Okay? So as I think that's a coupler, it's going to do one-to-one straight through, and then this will, spin like the standard, I'll store a degree of torque, that kind of thing. Well, Well, this, once the turbine spins up, the coupler part will finally spin up fast enough that it will engage the torque conversion part and finally engage the coupler part that is the torque converter. So it's like it will more or less not really be doing much. Then it will suddenly bite at the correct RPM. So that way it acts like an MGUK. Instead of making electricity, we make direct work energy. It suddenly makes the coupler spin faster. It's a part of the crankshaft. Direct from the turbine. It's not perfect. It'll get warm. That makes it more efficient though, because of higher pressures. That's fine. And you actually kind of want that, because you want to cool that just to a degree, because that's energy that would be lost otherwise. Alright. Now, not fully done with that, okay? You know, for the turbine part. Turbine part's a bit rough. You know what I mean? Like, you have to kind of understand that a turbine is weird. And you have to have that still input its energy to a compressor. It's going to be a standard turbo, if I'm being honest, with this, like a freaking funnel, hypervelocity stack, whatever you want to call it. You know what I mean? With some ribbing. A good way to put this is, it's a funnel with vertical from wider to smaller little channels on the sides. And then it goes to a bifurcation. It's like a radiator. So it's like it's a teardrop style, but bullet. And then in between the teardrop style bullet underneath, then you have, you guessed it, another bifurcation. That's a little bit of compression. At first, it seems like that might be restrictive. Not as much as you might expect at those slower RPMs. But then there is a moving fan that is your compressor. You get faster, it sucks. It actually helps the efficiencies of the turbo. Now, that's just a standard axle in this instance. That's why the coupler is still kind of not engaged for the torque converter. So it's like this was direct, and then once it gets to the right RPM, that will engage. Finally, all right. This is a standard this size gear. Okay, for the compressor. You don't want it to be anything other than this size gear. The Viterator clutch setup is attached to the little miniature V8 NQ90 just put out today. And it's, I think, August 23rd or something. So that, anyways. It's a nice little neat, it's 78cc, alright. Cool little model toy, but I was like, oh yeah, no, I can put this as a cool bike motor, bike engine, you know what I mean? Yeah, that's not terrible. I can get an intercooler, I can get a better radiator, there's nothing saying I can't do this. Well, how would I make this actually something I would like? Because I've got now fuel injection. I can't do, unfortunately, my two-stroke scavenge. Boo, boo. Okay, fine. And, you know what I mean? But, doesn't change. I can still ramp up RPM. So that's fine. I can get my multi-layer steel gasket. I can port, I can change. And this was the biggest one. Alright, so this is the one I really wanted people to understand, was the reason why it made sense for me to suddenly be like, well, yeah, I want a bigger turbine, I want all this setup. It's like, why? I mean, yeah, okay, so you got like 14 or double the horsepower, whatever, right? Torque, so on. But, well, I mean, with the efficient, okay, whatever. See, it's like that's a lot of expense. Why would you do it? It's cool, it seems like it's reasonable, honestly. It's, like, why not? It's the expense, though, you know what I mean? Anyways, moving on. This is a mechanical, and as a result, this is why I wanted to do this. Designed for a redesign of my valves. Okay. I was like, well, Formula One has tech. they have this pneumatic kind of thing, that's their spring. There's something to cool it, all that. It's like, okay, I can do a similar thing. Why not? I'm already porting this. Gotta get a bigger valve? Gotta get angles? I mean, I'd love to have an angle valve. No, let's just get around that. Let's just put the bucket or whatever in the pneumatics. Let's do it. Alright, simple. It's already that kind of thing, so simple. I can add that on. It's not impossible, okay? Now, what about this hydraulic? What is this? Hydraulic ram? Well, yeah, no, mechanical injectors existed. I can use fuel injectors that run off of a distributor, a second distributor, if you wanted to do that. It's this timing, this duration, this many pulses. Nothing saying I can do that. I already have a stator though, so it's going to be electronic. Simple. Remember? Simple. But it's like, oh, ding. Okay, so rocker arms. You remember rocker arms? Goes up, it goes down. Well, I mean, there's this guy that put out Meanwhile in the Garage or something on YouTube. This rotating tube designed for a valve. And they've had them before, and they've had sliding valves. Well, what if I put like an Archimedes screw in there and put some holes in there? In the screw part, and then put holes alongside the cylinder. It allows for it to, as it spins, with the serpentine belt like a camshaft, because I only need a single overhead cam. One. I'm still going to have valves that have springs. Okay, cool, right? Nice. Well, the basic simple premise turns into, well, fluid comes out, pushes hydraulic fluid ram, then it has a way to escape after pushing as it rotates. So it's like, that's a valve here that fully pushes it. This is a valve because a tube within a tube basically, or this is just as it rotates a gear, all of a sudden the valve comes in and allows for the exhausting of, while there's pressure from the pneumatic spring, out the hydraulic fluid. Because that's a given mass, blah blah blah, certain pressures, you can calculate, you can get it done. All it has to do is rotate alongside the cylinder, or be a part of the cylinder. Whole, simple, easy, understandable. I can use a hydraulic fluid pump and a better water pump. So it's a water pump that's bigger, but then I can then use also that to help run the hydraulic fluid. I can then use an electric motor to start the hydraulic fluid. I don't really need pressure immediately because it's kind of one-to-one, but why not? Pressurize it during startup. So it's like, start that up, it runs for a little bit, then it starts the motor. I have pressure, it takes over, you get it to return, because of course you have to have it return. It helps cool, still pushes, it's less weight, more controllable. It can change the valve size, it can change the lift, it can change a lot of that stuff for timing, based on like a venerator. So there you go. I have timing, I have duration, and lift for these things. Because I have the pneumatic, and now it can go all the way up to 25,000 RPM. Screw 500 RPM. Why would I do 500? I have electronic fuel injection, which says I need only that amount. I can pump more fuel into this. Why shouldn't I? I have more air. Why wouldn't I put more air in it? I can put more fuel. Why can't I put more fuel? I have a torque converter coupler thing. Of course I'm going to want that. I got that directly back, right into my transmission. It's bigger, it's longer, sure, yeah, okay, well, better. Might as well. And that's the creative process. It's like, this is already stuff I already know, though. You know what I mean? Pretty simple stuff for me. I've already learned a decent amount looking around, figuring out things myself, but also seeing what worked for others. Stuff. Makes sense. If you can do that, you can probably figure it out. Right? I'm learning, just like anyone else can. Okay? So it's like, alright. Alright. Well, I can angle the valves and make it bigger valves. Alright, let's change out the heads. I'll get my cross flow with the 2-star scavenge. It goes too far. It's already annoying. It's already expensive. If I were to go that far, I'm making stuff. Fuck it. So, they have chromoly steel, or chromoly molybdenum, or molybdenum steel, depending. Alright, those are alloys. Alright, so it's a 1/4 inch thick at its most. But it's not. Alright, so we have hyper-eutectic. So I already did this really quick in the past. It's like, why would you do that? Why is it? It's 49 cc's. It's not 78 cc. It's 49 cc's. It's a post piston. I have a center combustion and an outer combustion. Describe this real fast. Alright, so that's existing in a rail that goes in and out. That has a bearing. Top dead, bottom dead. On a plate in the center, where the center dead is. Alright? Those rotate. So those have arms, like an Atkins. Okay? So as they go in, they're at the top, they go back down to the bottom. Slide out, 93. Left and right. Slide in, 12 and 6. Top and bottom. I have a longer stroke, more torque. I want a higher RPM anyways. Well, you know, might as well put some good ceramic on it. Less heat, or wear resistance, less friction. Good stuff, right? With these little holes towards the center, you push it around, where the hyper-eutectic part slides in, and then you twist. Joins in, sticks in. And you have these pieces up for the outside. You twist them in, torque them down, they slide in. Those little rails, basically, is effectively what it is. That your initial hyper-eutectic went in. Well, this is, you know, stronger stuff, because it's the outside. But then there's a casing that goes over that holds the sliding piston arm. The piston arm's hollow. It's got long channels throughout it. Not flukes, is what some would say. I call them flukes. But they're not rifling. Make sure of that. They're just length. Same thing like the chromoly, molybdenum, whatever. Oh, you know, it's brittle. Okay, well, you know, it's also lengthwise, and now has support from a casing outside, and then making it fully solid coolant. Now, that's the hyper-eutectic, you know, all that. It's like, alright, so we have these ring valves. Talked about it like a top hat with a brim. They go real fast. So you get a brim. Now imagine there was a mushroom on the brim of the hat. What do you know? That's a bearing, it's sealed. I can put the, if you do it right, put the oil, hydraulic fluid in that, and then it has to go through the right angle, okay. It probably doesn't want to do that, so it probably won't get there to the oil. Oil can flow through, there's an exhaust, there's an intake. Alright, as it rotates, they're going to counter-rotate because two different plates. Right? You get it. Those are now sealed. The rings, they have holes in them. They're vertical and horizontal. Think L. With the long part of the L towards the center. Spark plugs in the center at the top, they're angled on the sides. Now, there's this little ring travels that forces air and fuel to come in, goes up to where the spark plug is, fires, and spreads out. Now, it'll go down further where it initially sparks, but it'll travel and, you know, throw a spark in, kind of like a 411. Same thing with the sides, but this one's just a bloom, like a flower coming in. It's a two-story scavenge. Alright, so now we have oil that we have traveling from the center plate, and then it's traveling along towards the bottom and towards the top. Alright, both sides. Goes up, goes over. Alright? Over goes down towards where these little valve holes. So these are another rotating assembly. Same kind of thing. Hydraulic fluid pressure can open the width. So it's like these are pretty decently large decently large is what we're going for, since apparently, everybody's trying their best. Okay, everybody has English as first language, it's okay. I get you. Now, what does this mean? Pretty simple stuff for me, and probably for you too. You can probably understand, as it widens, I get more airflow. It becomes larger. So take a hand, make a circle. Take another hand, make another circle. Let's see, bifurcate it. And then slide it over to the left or the right, depending. All of a sudden you have a full circle. There's my top. Simple. You can understand that. I now suddenly have the idea of lift. That's how I described it, because as a poppet valve goes down, you take a toroidal or donut cross-sectional area, because there's a stem in the middle and there's a flat part. It has to go out. That's why they angle them now, to try and get better volume efficiency. It's a donut. That's its valve area. That's its opening. Okay, so kind of the same thing. Well, the rings are not attached directly to those plates. There's a gear. As more pressure comes in, cone gears happen, and it changes timing. Pressure widens it. Timing changes automatically because of RPM that we're looking to hit. RPM targets. Kind of like the venerator, yeah. Now, this one's the big one. You're going to have to understand why I said that there's this oil. Because, hey, remember that piston head? I said the right piston rings, the right gap. And the skirts are pretty much flat. You know what I mean? Like, it doesn't have any concavity in the bottom. You can't have that. It's hollow. There's no wrist pin. Solid forged. This is lathe work, effectively. And it's slightly tapered, like your forearm is to where your elbow, but that's going to be where your wrist is. There's going to be a hole there. It's going to have oil flow through that. From the top and the bottom, goes around. It's going to eat some oil, it's okay. The oil from the top, where it passes through its version of a middle dead, between center dead and outer dead. Now it'll go from the top down to the bottom. Valve opens, closes pretty quick. It's a little oval, you get the picture, but it's going to eat a little bit of oil, it's okay. You gotta change oil, you gotta add oil to most engines. It's okay. Alright? Now, but that's also attached to a other valve system. As it slides through, all of a sudden it'll open and there'll be a exhaust towards one side and there's an intake towards another. Okay? Right. But intake has already happened over here, towards the outsides. This now has traveled far enough, exhaust goes, they don't close, but there's exhaust also towards the outsides that starts around that time when it closes. So it'll already have traveled forward, and then it'll turn back, increasing volumetric efficiency. Kind of a similar deal with the center. There's two rings, so two intakes, and then it'll have a little bit of exhaust, but then that'll close, and then you get the picture on the exhaust towards the center. So, whoop, comes in. More efficiency for two-stroke scavenging. Because they have a center two-stroke and an outer two-stroke. It's kind of like I have a one-stroke. It's not a one-stroke, but it's basically a one-stroke. It's basically, now, not fully done. I understand it's a lot to take in really fast, so, you get the idea that it can be hard to understand some of this when I go that fast. So I'm sorry, but I gotta get going. I want to take a shower. Okay, I've already been here over almost 30 minutes. Okay, so alright, now I now have lubrication. That goes off not just into where the sealed area is for multiple piston rings and tapering and so on for sealing, but that little sliding area, it's sealed, of course. It's part of the casing, so, but I also need it to be lubrication. But that's also a pump. Out, in, out, in. Well, now the entire thing is cooled by hydraulic fluid. This makes sense to do. Now it's just a radiator that has hydraulic fluid that goes through it, so good enough. Okay? Simple, easy to understand. I don't need two fluids. If something breaks, blah, blah, blah. You get the picture. I have fluid that comes in for the bearings. Now, let's understand thermodynamics for our valves. That will capture some degree because there's basically an intake manifold right there between the casing, the tube, and the valves. Okay? That kind of thing. It's going to rest inside of that. And there's two that you clamp. Well, not really clamp. They slide into each other, kind of like a. So there's like a clamp on your left hand, and then it's a straight palm, and it goes in. And then, of course, you have to slide it in between two vertical parts, right? You just have to have the stators, allow for air to flow in. Anyways, point is, there's a way to seal it. Doing that, it's more than good enough. You get the picture. Alright? But, air's in there, exhaust has to go also through that, but also through the ace, and also through the outside. That way it has more exhaust. Alright, and it's going to do that in such a way where it allows for the exhaust to first be cooled by the air that's already trapped. But then, as it goes out, and it rotates, air comes in, it then travels, is probably exhausted. With that exhaust, no longer is the valve too warm. It also happens to have liquid going through it that's cooling it. Called lubricant. So, you know. No more backfiring, no more pre-detonation, no more knock. Good stuff. So, utilizing everything I can here, right? Best I can. And I still have the same ram air turbo supercharger type of things, like ram air super turbo. Air to air, of course, you know, the liquid a little bit, you know, I didn't talk about that before, and might as well. Okay. Still got the turbine, still got all that. It's a longer stroke, but because they know, and the reason why I talk about this for 49cc, the reason why I talk about this at all is because it's like, you don't need a license. Like scooters are like 125cc, you need a license, right? It's like, well, I can strap this to my bike. Why not? So now I have no need for springs, a very high efficiency scavenge effect, 2-stroke, single cylinder, 49cc, because 4-stroke is what they measure for that, not all the combustion zones. 3 combustion zones. I can pour more fuel, I can put more air, get timing, get duration, kind of, not really, it's more lift, I guess, or separation or something. Now, I have my turbine, I have my coupler, and all the rest of it. So why would you do this? Because it would be, thanks to it being balanced, thanks to having really high RPM that I can be at constantly, thanks to a longer stroke in bore for that V8, I now have a more efficient, higher powered engine design with less friction. They can put more through it because of the materials used. Which now means my 78cc V8's been overwhelmed by a 2-stroke, which kind of technically a 1-stroke, single cylinder 49cc. Cool stuff, right? It's like there are other ways to do those valves. It's a basic concept. It's like, what ways would you do those valves? Leave a comment, subscribe, and like. But then I thought about it, because it's like, well, you know, I started this whole thing kind of as a Formula 1 project. If I ever worked for Formula 1, it's like, remember that radial, or rotary, you know, the whole, you know, that thing? With like the bump stops, and then they have gear teeth on that, and it goes down, and it goes over. Same thing, inline 4, perfect balance now. Alright, perfect balance. But now I have the Lemke cycle, that's what I call it. Instead of Atkins, this, and that, Lemke. Full duration of that stroke, by the way. the power stroke is captured during that because of that type of axle that's there. But this is where the heads are different than anything else. It's basically an exhaust from a rocket, a built-in rocket. It's effectively what that is. Pump in a little bit of air and fuel, it goes back to compression, ignite, pump in more, get the full duration power stroke, goes back up, like a Brayton cycle, boom, 3, 4, and exhaust. Do it again. Got my 4 strokes. Within the rules. It was like, well, they're willing to pay me money to build an actual engine, not their garbage, regular stuff. Actual engines. So it's like, this material is a layered material that is the thermophotovoltaic, thermoelectric, piezoelectric, coolant, cylinder, and block. About the axle, about the piston rod, all that stuff, and how that works, so we're not going to get into that. Instead, it's like, well, guess what? Now I have the electrostatic, electromagnetic, kinetic, and momentum amplifying motor. That produces electricity. Now we have the, I already put it out there, waste heat generator, Jules Thomson, thermoacoustic. I have the thermocouple. Well, nothing says that, well, actually, wait, no. Well, I mean, a couple, right? The torque converter coupler, it's going to be a little bit thermocouply. It's like, well, why not? Cool it a little bit. The turbine, the in, out, and then as it goes towards the tip, it gets sucked, turns, goes back up, recycles a little bit, but it has to travel all the way to the rear, where it's going to turn over and then go back through that. And it's hollow with those, housing, within inside of a housing, but also the blades to a degree, and the stators. It's a turbine within a turbine, effectively. Goes forward, kind of like a Peltier, and then turns around. But then it has to rotate things, but it does it in such a way where it creates a vacuum, so it has higher flow. And less pressure. More efficiency. And a degree of that is sucked back into the inlet flow. 4-to-1, standard, vacuum, ceramic, insulation, but just in case, in the right area, piezoelectric, thermoelectric, thermophotovoltaic, and you got the waste heat generator, you got the RAM, you know about that. It goes directly to, of course, the electric motor that's part of the axle, and the housing for the block. It's got balance, full duration. Now it's the Lemke cycle. No longer is a Brayton, because I have a rocket exhaust, of course, so nope. I only ever exhaust, like a 2-stroke, but not really. I have a different axle, over crankshaft like that. It's a longer stroke, tighter, more compact. Then the after turbine, guess what? Yeah, I already talked about the muffler or the piezoelectrics. Well, I don't need that. But I want that electricity. So I can still cool it, I can still have air go through it. That's aerodynamics. Why not? Heat, squeeze, piezoelectrics. And diaphragms for, you guessed it, Starlings. Cools it. Still allows for it to go through quick, but it's not as pressured. And capture most of the heat into electricity and directly into the axle to your transmission with the thermal, well, not thermal side, and the thermocoupler. Nope, just the, you guessed it, torque converter coupler, because apparently you're trying to get it in the way. You need to leave, you need to leave, he needs to leave, he needs to get out of here. I kept hearing that interruption. I kept trying to work around it and keep going. They're shit. I don't like them. Lemke cycle now. Perfectly balanced. 4 power strokes. Exhausts the one time. 4-stroke standard. But I can do technically 1 stroke if I'm being honest. But nothing at the bottom is there. Still have standard oil, all the rest of it for cooling. Better, more efficient. lighter weight, more efficient, much higher efficiency, 70, 80% roughly, you know. I'm still going to have the full, all of it that I can get. Well, do I need a bigger turbine? I mean, it's going to be, to a certain point, ridiculous past that point. It doesn't make sense. But that coupler, torque converter coupler, because I can make a different couple of versions to help with that, you know what I mean? But guess what? With the right batteries and capacitors and circuit and that together, well, I make more power across the board, all RPMs. In fact, I have, for the fuel that they're allowed, that they're given, the pressures they're allowed and given, all the way up, because of course it's perfectly balanced and all the rest of that, beyond 25,000 RPM within the fuel range. That's right, I do. It's about the exhaust, about the timing. Got the hydraulic fluid, still mechanical, still works. It weighs less, it's less dense than a regular camshaft, still works. Push and pull with the redundancy spring. Push in, pull out, spring, doesn't need to be as much, doesn't need to be big, still works though. You know about like the whole cross port thing, you know, diagonal stuff? Well, now I don't need that. Now it's directly down for the exhaust. Now I need that to help with the rotation and continuation of that exhaust coming out to reduce pressures. It's diagonal, it's angled, goes right next to the cylinder sidewall, basically cups it as it goes through, it'll start a rotation, and it'll go out faster. Beautifully angled to a turbine. It's a longer turbine, sure, yeah, but better, more efficient. Why not? Why wouldn't I use it? Makes no sense not to. Hey, you're willing to pay $10 million for that? Give me a shot. $10 million, I can make this. With all of you and your help. Absolutely. Smoke the fucking goddamn rest of them. They can do nothing. This is the truth. But, oh, okay, alright. I have to use this type of crankshaft. Alright, I have a couple other crankshaft designs. I don't have to just have this axle with all that. Alright. It's kind of like it's offset. Instead of all this spring blah blah blah. Breaking. Get rid of it. Don't want it. So it's like, as it shakes something side to side, it goes up and down. They're in bearings. Okay? Standard bearing, it'll go forward or go back, but it moves on a bearing. Kind of like a Scottish goat, but it's sliding no more. It's got a bearing. The bearings are sliding, but whatever. You know what I mean? Anyways, those have, instead of balancers, you know, like the standard big, whatever weight those are, these are vertical. They're kind of shaped like oval. It's another bearing part that's attached to it. But this can have plates now. And those will be attached to that. As it rotates up and down, it's kind of like it's offset. As it goes over, as it extends, goes back, you have the double wristband, standard stuff. Those go up, those goes down, they go side, side. They slightly tilt as they do that. That's my pump, my hydraulic fluid pump. If I have it squeeze a little bit over there, and then it goes over, that's a pump. You can see it? Take a little U, two lines for a rainbow. Now, imagine one part of the line has a sine wave, and then it travels, which just means a bump. It goes up to the top part of the line, and then it travels over. That's a pump. Same thing at the bottom. It's a pump. I can put air there, I can put fluid there, put fluid, it can also help pump air. It's like a supercharger, right? But far more balanced now. less weight. Came up with the design specifically for these large, ginormous engines for boats. Have you seen these fuckers? Huge! Why don't they use this? This makes no sense. I mean, it barely has to move, it'll balance the thing. Yours would have to move a little bit more, but you get the picture. Perfectly balanced, standard type of kind of crankshaft. No more harmonics. With a head design that is the Lemke cycle. Combination of multiples, if I'm being honest. Yeah, I think it's so cool that. That's my super turbo now. Woohoo! Super turbo. There you go. Formula One still works with your crankshafts. I'm allowed to change crankshafts. It still works. It's within your rules. Even the other one, honestly. It's perfectly balanced. I don't even need that. But yeah, there you go. Same thing with the head. Oh, you don't want that? I have a rotating valve. Two things cross-rotate. They open, comes in, goes down, scoops up. I don't need the scavenge. I wonder how much I'm allowed for what it's worth. Yeah. But anyways, opens, closes, rotates. Don't need springs. Still gets cooled by hydraulic fluid and gears. Turn it instead of the hydraulic fluid, which I usually use hydraulic fluid, but you know, they can use hydraulic fluid. This coupler will work. You know, there's correction methods, increasing pressure, so on. It's less weight, but why not? It's a gear. It's more reliable now, kind of. You know what I mean? Then you have to change out the gears, but you're willing to change out gears. But you still got the engine block, still works. Still got the waste heat generator, or the radiator, which is the Joule-Thomson phase kind of sort of change. It's really pressure differences with the acoustic pump. Starling, piezoelectric, heating, squeezing, movement, piezoelectric, heating, squeezing, electricity generation. Same thing with the, you guessed it, exhaust. Fuck. And, oh, you guessed it, turbine. Electric motor. We'll just use your regular electric motor. Okay. Well, yeah, sure, why not? If you want to. I have a way better one. Works way better, but okay. Way better phasing system, way better all this stuff, if I'm being really, really honest. You should really look that up. It's on my YouTube, but you get it. You know what I mean? Like, it'll work. It's far more torque. Really good an energy input. And actual horsepower. What's worth. If I can put it in directly to the block, I mean, that's the casing kind of like, do, and it's like, that's part of the axle. What do you know? Works. All one piece design. Highly reliable now. Should work very well. I'd still test it for a little bit, but it should be reliable well past theirs. Way less failure. There's nothing saying it didn't do the rotating valve, I'm just saying, with my exhaust. It just has to open up at the right time, but that's a gear, a rotating part with another rotating part that's sealed. You know about the top, you know about this, you know about that, so it can work. It's just a circle. It's flat, or curved, or whatever you want to do, for being honest. There you go. I think I could win. Honestly speaking, I think I can join in on that. I could make this Formula One engine and I could whoop some people's asses. Granted, it does depend on the driver. It's not just engine performance and efficiency. You know what I mean? So, there's that part. And I got some aerodynamics for the whale fin bumps and, channel groove things and, skippy parts that allow for it to skip over, and then suctiony vacuum parts that I've talked about in previous videos. No longer do I need valves, they're not moving. It just does it automatically depending on the speeds and the size of what it is for your aerodynamics. Yeah, I got more downforce, less drag. More power. Eh? Less weight. Is your driver good enough? Are your strategists good enough? Can your principal, your team principal, the boss, really make it happen? Because I can't do more than that. I'm not you. I can't do that. I can play around, but I'm not that. See what I'm saying? It's a team. I can't do all that. I can do this. I'm good at that. You gotta be able to be good enough for that. I can't make a driver suddenly better. Can't make strategists make better calls, or the team principal manage people better and make good calls too. Can't do any of that. That's that are you good enough part. I did the best I can. It's in your hands. Worked within your rules and your limits. And I smashed it. I can go way the hell higher than 25K. Truthfully, I'm hitting around that 45K range for the given air and fuel that they have. That being said, I really doubt I would do that, because then I can run way less weight. I don't need that kind of horsepower. I don't need that kind of fucking torque. So it's like, oof, less fuel, less weight, faster, easier to slow down, brake later, faster. Better aerodynamics is the best I can do. I have some ideas, but there's only so much you can do. You have sponsors, and all that. You get the picture. No aerodynamicist, a fluid dynamicist, although I kind of know a thing or two, but nothing like that. Nothing like an engine near, but I can hold my own, I think. So there you go. I would fit. I have a place. That's what I say. Because I look at my battery ideas. They're field effect. So like electrostatic. But that holds, for the actual solid state battery here, a different charge potential between the solid state. Well, they also have their own charge potentials, which also means I can put more electricity within the solid state area. And I can make them down to a microscopic level, structure them, put piezoelectrics in between, heating and cooling, electricity running through. I get a little bit more electricity for the given size and shape and design. I have more battery potential. Less weight. How much battery do you want to run? I can also do capacitors, yeah. I have amazing amounts of capacitor stuff. Although, for what it's worth, electrostatic and electromagnetic differences, charge field differences, There's only so much you can do with that, for what it's worth. But if you do it the right way, with the right microscopic, mini, little milli, and then you get down to nanos, you can make multiple structures of field differences that collapse inward, kind of like a volt, field that collapses, winding, so on. But different in this instance because a large solid state field battery, effectively, but it's not a battery, it's a capacitor. It'll charge like a capacitor. It'll hold a pretty damn good charge. It'll be fairly small for what it's worth, but it's a capacitor. It's not a battery. It's a capacitor. It dumps it pretty fast over time. Charge pretty fast too. To a degree. So it's a real scary one because it's like, oh yeah, no, I can charge it fairly quick. You know, my thing over this and plug it in. Brrr, done. All right, there you go. It's a little warm. Yeah, I wouldn't touch it. It's a little scary. It really wouldn't touch it. Sure, it's not warm. You know, but at the same time, it's like, it'll handle that, and it'll do it for years, if I'm being honest. Although you get decades if you don't do it that way, so there's that. But, if you want to imagine it like, no, I've got 5 minutes, you got 5 minutes? Oh yeah, no, I got 5 minutes, why? 5 minutes. Oh, there you go. Almost no real heating up. Still gotta heat up a little bit, not much. Yeah, good. Scary shit, right? I haven't talked about them too much, but most of them are basic, kind of simple, simplistic designs. So it's like, you know how charge fields exist for chemicals, like organic? Acidic versus alkaline, you know, like ionics. Kind of similar idea. Instead of winding coils and trying to store it. It's like, well, chemicals with the right coils, with the right material, with the right structure, instead of a crystalline, with the right insulator, which absorbs and puts it back. Structure, bigger, like a polycrystalline structure with this one, allowing for that. Puzzle piece together. Boom. It's a big old, tiny little capacitor, you know, for its worth. It's kind of flat more than anything. Yeah, it's got a rectangle. But anyways, it's a capacitor. It's like a MOSFET field effect. You know, kind of like MOSFET, you know, right? It's field effect transistor, but instead of being a transistor, it's a capacitor. It dumps a lot of energy for quite a while, but it's not as big as like the actual battery. So that's, you know, whatever. It's like, alrighty, let's go to race, right? You know, yeah. I don't know if I want to accelerate that fast or slow down that fast. Are you sure? If you're not the racer for us, then let's find them. Let's go find that one. Let's see. Alright. Talent scout and all that. But that's what that would be. Because I would honestly say, I don't know if I want to. So you're not gonna be. That's what that would end up being. I get the joke or whatever, but you can't say something. You have to actually want it. That being said, it'll probably have to go to either I make one and somehow come in, or an established that somehow was able to get in and get this going. And usually there's a whole bunch of seniority. Meanwhile, innovation is being slowed. Let's go. Let me get my kinetic accelerators over here. Huh? No worries, it's just a part of my axle. The hub. You know, I put that in. Huh? You're not allowed to do that. No, it just takes energy from the ground and the air. The differences. It puts power back into the rotation. No electricity from our engine, anything. But fuck off. It's automatic. Oh, you are a wonderful motherfucker. There's no rules. I hate that though. Could you put it in the I could, yeah. There's nothing saying I can't put it into the chassis. Let's go. Brrr. I don't need this. Oh, God. You start understanding, it's like, oh, no, let me just accelerate you at 1G, past 1G. What's their actual G-force you think you can handle? Because I can decelerate you using that, the same thing. Yeah, I'll still use your brakes, but don't worry. This will get you. How fast do you think you can decelerate consistently over an entire course of a race? Please don't. No, I don't know. What's the human load? Let's train you up. Can you maybe make a consistent 3G for me for like an hour?
We do 5 to 7. Alright, let's go with 9. Let's try. What? No, that's not consistent. Those are burst loads. Oh, okay. Let's do it 9. Burst load then. What do you think you can sustain consistently? 3G. Alright, let's do 3G. Consistent acceleration, deceleration, burst load up to 9. It'll drop back. Does anybody else feel this fucking fear? No? Alright, good. That's good. Let's go. This is fine. It's fine. Hey, don't panic. It's okay. Remember to breathe. We got you a flight suit anyway. Oh, thanks. Why are you making the front? I wonder. Ah, so you were the guy. Let's put the person, woman, guy, whatever. Come on. Yeah, let's watch them. This is bullshit. They're fucking cheating. There's no cheating. I'm working within the rules. It's true though. You're bullshit, you know it. Nah, I'm allowed to do this. The rules state I can. Physics also says I can. Sicky. I finished with 20 laps left. You're go fuck yourself. This is what I would hope for, honestly. Could you imagine? Holy shit! Lewis Hamilton, any of them, right? 20 laps for the person in second. Oh, thanks. Freaking dick. Oh yeah, thanks, man. No problemo. This is all you guys. Oh, bullshit. I got a thing that could probably fly me to the moon. This is bullshit. I know what that means. You. The rules state I'm allowed to do this. There's nothing saying I can't do this. Inertial acceleration? It's an engine. You're not allowed to have other engines. It's a part of the engine. Okay, well, it's part of the engine. Hey, it's a hollow axle, so I can use it. Oh, not in the. It's. God, I'm gonna fucking die. That's the first thing acceleration the person can fucking do. Oh, great. You know, just getting near the very edge of fucking traction. Yeah, no, that's the kinetic accelerator. The inertial accelerator engine. It also has dampening. This is braking. Oh, great, yeah, you know, oh, well, you know. It works, though. Yes, no, I'm a, You think you can sustain that for a whole race? Nah, the max is really the max one time, so, you know. Yeah. Oh, God. Yeah. No, but, you know, you can figure it out. It's up to you. What your reaction time can really do. And what your body can really handle. Yeah, I know, right? It's like, well, my body can handle more and have better reaction time. This would be a cheat mode. I'm not, like, hitting Apex anymore. You know, this is fucking stupid. Still has really good traction. You still be able to hit those Apex. You probably have different lines because of how fast you're going, but still. Yeah, I know, I get you. It's like, this is just a little... let's fly! No! Are you allowed? You're not allowed to fly. You have to have the wheels in the ground. So there's that. Yeah. Teleport around. There's nothing saying I can't, technically speaking, do that. The wheels are always on the ground every step of the way. Boop, 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 boop. I've counted the laps. Just saying, dude. Bullshit! You would have to do some things, honestly, but still, yeah, no, you're right, actually, a little bit that way. Sorry, we got a little bit, but he got angry. Yeah, I'm fucking pissed! Fuck you! Really? Wouldn't even fuck off! My sport! That's a fair point. That's a good thing we would probably do that. Yeah. You know what I mean? Probably. I probably would never do it for what it's worth. But still, probably. What if I was into sport for hundreds of thousands of years? It'd make really, really large, multi-universe sized tracks. Boop, 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 boop. This is bullshit. I have the technology. I learned. I listened to the YouTube videos. That's fair. That can happen. Alright. I'll pay you to take him off the friggin' YouTube. How much are you talking? Like for real. If you were really, honestly. How much are we talking? Anyways, there you go. Let's pause. Think about the creative process. What is it you want to achieve? What do you think you need to have, or to do, or to focus on to achieve it? First two, okay, mindset changes. Now, we're going to address, okay, so we have the do within a do within a do. The 49cc. Don't worry about cooling, you can get cooling later. You know, bifurcate all this, the return over the top, or this, that, whatever. Worry about it later. I already have my design, I know what I did. I talked about those valves. There are multiple ways to put those valves together. I use that one because it's easy to just roll them, basically, and then they're done. Stick them together. Slide them in. Really fast for manufacturing, they'll work well enough, they're easy to take apart for repair. Okay, kind of a decent idea, I thought. There are other ways. We're talking about it, there's the horizontal, like multiple brims, and then like a, you know, you put like a piston ring kind of style, or it goes over that. 6N is seals. It still allows for it to rotate. Like, super cool. And like you still have to have the bearing underneath, right? That allows for it to rotate with a gear underneath. Still will work. It's okay. It's not more complicated, but you know, it's what it is. It's like I felt like that was something I would do, but there are other ways, and some of them could be more or less, and better or worse, depending on the perspective. I call it perspective. And this is perspective. It's like manufacturing. Would it be better? Is it slightly more? I mean, a piston ring? I can do a piston ring. A couple brims, I can do that. You see what I'm saying? You know what I mean? So it's like, oh, why chromoly or molybdenum or a combo chromoly molybdenum steel? Super hard. Even though it's a 1/4 inch thick in some places, other places it's not as hyper-eutectic aluminum. Really quickly dissipate heat. It's great for wear rate, great for hardness, because it's, you know, along the length of the cylinder, it supports cylinder pressure. Even though it's kind of brittle, well, guess what, it'll handle it better. It'll flex a little bit, but it's okay. So that's why I thought about that way. But
But there are other ways to put it together. So it's like creative process. I think you're sort of probably gonna end up having the plate. You're gonna have that transfer somehow to somewhere. Yeah, so it's kind of like a push rod packet cycle sort of thing. Sure, okay. Well, no, it's not that big of a deal. It's really not. And then because I have bearings, I'm going to situate myself in something that's sealed with bearings and it's got lubrication. It'll work for a while, and it's easy to take apart and repair or change anything out. It can go pretty high in cylinder pressures, pretty high in a lot of things. But of course, there's only so much you can get out of gasoline, ethanol. You get the picture. So that's why the 2-stroke and higher RPMs. It's typically what I ended up doing. But you don't always have to do that to get that picture. Think about the process. From this to that, to that to this, to this to that. It's like programming. What step from that do I have to go to from that to get this? And from there, what does that lead to? And what do I want it to do? Picture it in your head, the tube. Picture it in your head, the valves. Picture it in your head, all of it. But don't. Not all of it all at once. Just focus on one part at a time. Go over everything that you can. Do it again. Be excited. Be, I did, like me. Or don't. Whatever. Write it down. Go over it. Do it. Again. See if you missed something. See if you can figure out something better. Come back to it with a fresh perspective. Do it again. See if you can learn something or do something better. Yeah. Change, done, that, whatever. Take a break. Come back to it. Do it again. It's called refinement, but it's also called, finally, the creative process. This is the real creative process. Rough draft, basic concept design, then a rough draft, then a final draft. See what I mean? It's 3. You have to have 3. Just like story writing, just like programming, just like any of it. 3. Try it out. You never know how far you might get. Alright, so I have taken my shower. Alright. I was naked the entire time I was talking to you, practically speaking. Just had to know. Were you naked? Yeah. Yes, I was. Well, we're going to talk about a little bit more. So it's like, they asked me why I didn't include this, so I'll include it. While I was taking a shower. Whoever they is at this point, there's a couple of fucking people. I have to deal with that. So, anyways. They ever want to say, I want to confirm. Anyways, moving on. Jeez. Could we? Right. So, it's a trapezoidal, so conical gear. You know, the center, like the plate that I talked about. Except there's an axle in the center, but it's not. It's 2-piece. So you bolt it, you screw it on, you torque it, and then there's like a plate that's in the center. There's a bearing on that side, on the outside of that, and then there's a bearing on the casing part, and that keeps it. And so that way it doesn't allow for it to go in too far, push in. Okay, for the, the gear part. It still rotates along that. Alright. How does that work? It's kind of, I call it a gear, it's not a gear. It's a whole thing. So you have to remember those have bearings. And so they're not positioned the same way, I suppose you would imagine. So like, I say, here's a plate. Plate's too simple. Kind of an idea. But it doesn't really matter. Anyways, a good way to put this is, so it's kind of conical. Okay, because it needs to be. That allows for the 2 rotating rings to situate themselves inside as it rotates.
Yeah, it's okay. Honestly, this is gearing and plates and all these other things talks, which is difficult to be able to imagine. It sounds like I'm just talking about my ass, and I'm trying to, spin for time. Almost inevitably going to sound like that to various degrees, you know? So, let's think about it this way. In order for this to not press in too much and put too much strain on it, in order for it to match, like, the fact that it has to go in a casing, and the casing has to both seal it, but also we don't want it to have too much of the strain placed on it. Okay? Standard stuff, right? Because, like, you can't expect the casing to take all the load. You have to have some of it be the gear, ring, valve stuff, and you have to have some of it be the rods, and you have to have some of it be the cylinder. That makes sense, right? You describe it as a plate. It's because it makes sense as a plate. You can imagine it like a plate. Technically speaking, it's two rotating plates in a way, and they're conical kind of slightly to each other, kind of like a hourglass. Then you have to have the gears as they rotate in between. You have to have the internal part that keeps it there. Alright, so that way it presses against the rods, and it presses against the cylinder wall, and it has a plate in the center to rest against, but still have that transfer its energy and rotation to it. It still allows for it to go in, down, and back out, because they're on the outsides. Correct. And then it has a donut where the plate is. So it's like that's the seal. Goes out, goes in, and same thing with the other side. Okay? Same stuff. So it's like, oh, do you see that he was not stalling for time and he knew the entire time? Oh my goodness, it sounds like you were definitely barking up the wrong tree again. Yeah, weird miscreant. Anyways, moving on. Phaser, stop. No. Don't. Stop that. Hey. Trying to bite all of my clothes as I put them on. Thanks, Phaser. Anyways, moving on to the bigger kind of question. Being honest. Again, real quick. Okay. Well, the sliding part still works just fine, right? But I didn't want to do that. Not because I was special, but because I understood balance and harmonics. So it's like these outer parts, they are a version of the hourglass. They rotate in, they rotate the axle. That also has a seal there as it slides. Then there's a, you guessed it, standard kind of like a crankshaft, sort of bigger arm, like a bearing there, that's attached to it. So it goes up and over, and that's attached to the casing. So it goes up and over, not center straight in, or a little plate circle. Now, what does this help with? Because I was talking about it for that crankshaft idea I had for the supercharger undulating style air pump. Well, same kind of thing. This helps with balance. As those go out, those go in. As this goes out or in, these go back out. And that goes and does opposite. And then you have the opposite rotations. And that also helps with the rotation through some gears along the between the casing and the cylinder walls. For the other rotating ring valves, I'm still able to seal things. That allows for pump forward. Then it has a vacuum. That's a sump. Picks it up. You get the picture. Because of the plates and yeah, okay. Standard kind of stuff, yeah. But it means it's stronger and it's more balanced now. And it also has more torque. That's right. For the given duration of its length of travel, I have more torque added to the plate in a way that makes more sense now to say that it has way more torque than it normally would have. Do I weigh roughly the same amount as the 78cc V8? Sure, yes, I do. But I make way more torque and way more power because I have a higher RPM. And I can put more pressures into it. I have far more leverage than your V8. And it's balanced. Very, very balanced. Because those are individual rotating styles of air pumps, along with the oil being pumped, which is our coolant as well. Alright, all good stuff, right? I felt. Makes it balanced, makes it tougher. It's kind of as good as it could get, but then they asked me about, oh, you're going to sell it, you're going to put it on bikes, all this, manufacturer. I was like, alright, yeah. So now it's the rocket injector. It's an injector that's a rocket. It injects both fuel and air together, ignites and pushes rocket. So then it has only the one rotating valve now instead, because that's all I really need. Exhaust near bottom dead or a little bit after bottom dead, and then if you know about the injector, it's this spinning part that goes up and down, so kind of like a donut. As it spins and it goes back up, it spins, but not, oh, it spins one way and then it turns around and spins. It continues to spin. That pushes air and fuel together into the nozzles. It's more than hot enough after a little bit of a spark, which you can put in there. And you get the whole brrr head. But now I have 3 of them. And no longer do I need the 2-stroke scavenge effect. I have higher pressures. And then it was like, well, here's a 3-tier instead of a 2-tier. Instead of, the standard forward and then it goes backwards. Goes forward, goes backwards, and then goes backwards from that. So it goes up, out, then back, and then up, out, and then back. Like a Jules Thompson, just bigger. From the smaller to a medium to a larger. Now it goes from in one way, goes out the other. You didn't have to do that, because I usually just had a tube that goes off to the side, a little bit of the scoop that goes into the intake. Worked out just fine. So, it's more compact in a lot of ways. But, here you go. Now it's a jet engine too. That's right, it's a jet engine. Compresses, ignites, sucks in more, comes out faster than it came in, more hot this way. So why not? Just more efficient too. In a smaller compact space. Instead of 3 feet long, I can now have a 1 foot. It's longer. No way now, it's wide. It's a wide boy. It's a big boy. It's wide. 1 foot? Yeah, no, depending on what you're looking for, it can go all the way up to 3 feet across. So there you go. Now I have way more thrust and or turbine as a capture. If I add in electricity, because of rotation, heat, thermoacoustic pump stuff. As it rotates towards the exhaust, I put the right bell end, air spike. As fluid goes from forward to rear or rear to forward, dumps heat, electricity, exchange, a little bit more exhaust, coming in with air and some heat and electricity and some fuel. Air comes in, ignites, but then goes through a plasma to plasma, exothermic in this instance, because that's hot enough and electricity is enough, so on. Plasma from the air, plasma from the exhaust, a little bit more fuel, a little bit more air, collapses, no longer plasma, goes through the cooling bell end, condenses, accelerates, orientates with the thermoacoustic for laminar directed flow, but it's kind of like a coherent as it bounces from the sides of the bell end. Okay, so it's like this is a version of the raindrop with an overhang. So it goes raindrop and has an overhang and then it trails off. And then same thing with the bell end. The bell end, or not the bell end, the air spike is hollow. So it has another version of the same thing on the inside, and then the outside, you get the picture as it has to have the right thermoacoustics and so on with the diaphragm and blah, blah, blah.
So anyways, it goes in parts, then goes and does the standard right-hand rule, conservation of momentum, spin out to the bell end, then goes back down, and in, and in, and in, and out, and in, and out, and in, and out. Creates some degree of turbulence, but it creates a lot more capture for the given outflow of gas, while it also comes out more coherented laminar slight vortex, but mini vortexes that then trail off to the edge where the waveguides into the bell end. Into the bell end has waveguides. Yes, no, I know. So terrible. Stators, all that. You know. And flows very consistently, but is captured, of course, by their own, because they're stators and they're wide versus small, and then trail the right way to overhang, and it captures that. And what do you know, for a given size of package with some props, electricity, intake, the exhaust from a standard engine, a little bit more air coming in from that, you get the picture, a whole bunch of stuff. Huge, large jet engine prop turbo thing. Goes really fast and hard, I'll tell you that much. The problem is like, this is actually kind of dangerous. Yeah, it's like, well, luckily I'm not burning the atmosphere, no nitric oxide. It comes out as regular, it's not hot enough. Still atmospheric pressures, which is good, because it exothermically collapses, uses the heat to help the whole process, make it more efficient. Captured for thrust, as it condenses, it accelerates. Then it goes through from nozzle to bell end, and you get the picture. Which bell end and aerospike are both basically double bell end, aerospike kind of things. Helping also the thermoacoustic and the cooling effect. Capture of energy, electricity, thermophotovoltaic, thermoelectric, and piezoelectrics, and movement, mechanical, blah blah blah. Do it the right geometric shape, with the right give and take for given spring, tension, thickness, so on. Brr, passive. Does it automatically. Alright, that's my dog. Runs in place going after its tail. Now, you understand why that kind of reminds me of some people? Just some, maybe you. I'm chasing after everything that you say. It'll work. Well, yeah, no, actually. Accelerates the hell out of it for the given heat. I'm not taking all the heat, but for what it's worth. And then guess what? There's a shroud there. And that's a heat exchanger. Heat, another shroud. Small to larger, back to small. Exchange happens. Phase change occurs. Jules Thompson, like the center prop spin shaft thing. Ah, right, yeah, well, still not done. Electricity, heat, plasma for the beginning, then this aversion, kind of the Jules Thompson Tesla valve stator area, effectively. Otherwise known as a Lemke cycle jet engine. Rocket engine. That's right, I'm John Tyler Lemke. Here we go. I'm going to put so many Lemkes out there, man. I got so many principles in my quantum physics, I can't even imagine how you're not going to give me a world record for Lemke principles and fucking laws and shit. But that's what it is. But anyways, this is another version of that. So heat exchange, electricity, mechanical work to thrust. That's effectively all it is. There's a thermoacoustic, it changes. Stirling is kind of like that, pressure differentials. Ventrilis, you get the picture. That creates electricity, but also not just electricity. We have to dump that electricity and heat some. You get the work energy to conversion, from, you get the picture. For the thermoacoustic, so on. It's a pump. Yeah, well, a pump's what everything kind of is. Because then I was like, okay, so let's talk about how it is that we're going to sell this for $1,000. The 49cc package. That's right, the 49cc package.
because I can make a bar bigger. You see the smallness, the size of these damn fucking piston heads in this V8 mother. God damn. They were like, oh, it's another V4. Nah, fuck this. This is making a longer stroke. Yeah. Anyways, it's like, right, but you get the heat exchanger. That's the waste heat generator. Because might as well. Why not? You get the engine, of course. You get the Ram turbo supercharger. No longer do I need like the ventilator, right? I still need the ventilator. Whole thing. It just needs less size. Because it'll work off of the kind of thing going on. You know what I mean? Right. Anyways, that exhaust, you get the torque converter coupler thing. Transmission, you'll have to find your own, but this is standard clutch-driven transmission. So motorcycle stuff. Or scooters. You got the turbine, end out to end. This thing, the triple, like Jules Thompson, is wider. It goes from small to wide, back to... You get that one. And then you have the muffler. You get the muffler as well. Okay, so like the muffler happens to be there too. Good stuff, right? I thought. Okay, right, yeah. But that's the heat strain change, the piezoelectric stuff. Pretty easy. Extrude, have this, have this outer, some, electrodes, kind of all that. You get the picture. Anyways, that also is the whole thing. It's a lot for 1,000, even if it's 49cc. It's a lot for $1,000. I don't really know. I mean, it really depends. Pressures, fuels, so on. I'd give you a solid 50 horsepower, good 30 to maybe 50 foot-pounds of torque, depending on what RPM and heat you're at and so on. So, that. Standard motorcycle. 49cc doesn't weigh nearly as much as yours. Way more efficient. Alright, good stuff. We're not quite done yet. Okay? It's like, alright, so here's the bike frame. You get tires, you get brakes, because you'd never use this on a regular bike. Why would you do that? Yeah, just sell the thing. You can always buy the bike frame and the tires. So it all comes together in one package. It's $1,000. Yeah. So you get this, they're wide tires, but they're not, motorcycle tires, but they're different because they're similar. All right, they're bead locked in this instance for the rims. They still get filled with regular, air. There's no tubes, gone. Still have, the steel belt, but we use Kevlar and some other stuff, and they actually do exist, just like that. Great stuff, right? They're a little wider, but they're more flexible as a result of that sidewall being a little bit longer and so on. But here's the kicker with the rim. It's sealed on the inside, but also on these tubes, the spokes. We don't use the tension spokes, we don't use standard rim spokes. We do use rim spokes and we do use tension spokes though. So how do I do that? I use vacuum, near perfect vacuums. On the inside at the top, like a T, and then on the spoke part in the center, with a thing around it, to a degree. It's just needing to be sealed. It resists going one way, and it resists going the other way. It uses vacuums, though. It weighs less. Tires weigh less. The rims weigh less. There's piezoelectric diaphragms. Because, of course, it has to have pressure. And the tire, as it squishes, it's going to squish this, what do you know? Electricity. I still have a standard, floating, though, motorcycle, drilled and slotted brake. High performance, because you're going to need it. The frame is not a regular type of frame. It's a soft tail, and it's got the wide enough yoke in the front and so on. And it's not a short bike, it's a long bike. It's not a recumbent, though. You're supposed to lean forward. There is a recumbent one, though. No monkey bars, but you can put it on there if you want to. Now, The yoke is a standard spring and shock, but this one uses, you guessed it, vacuums and a fluid. Of all things, what fluid? The air around us, having to pass through holes. Stirling effect. Pressure, not pressure. Resistance. Change of motion. Spring and shock. Automatic. Don't have to do anything. Got some electricity? Sure, why not? Here's some magnets and some coils. Why not? You can change spring and shock. Fine. Tension, stiffness. Why? Because it's all now really, really supported because it's within what it looks like to be a fully hard frame. It's not, but it looks like it. Looks like it. It'll slide, it'll change the geometry, it'll have bearings, so on. So, it'll move. It'll be just as soft as you want it. Much stronger now. And what he knows, there's some piezoelectrics. Here's your, battery. Here's your gas tank. Here's your seat. It's only 49cc, officers. Yeah, built for this with the standard muffler, but the muffler and all the rest of the pieces, you can bolt them together with some gasket and so on, and you can change where it comes out. Same thing with the intake, to a degree. You still need to hopefully prefer the ram air, but whatever. Still got in this instance though, because I really like this more than other things, this is the water and air intercooler Jules Thompson phase change. So it's a low pressure water, goes through for the ram air, has little slots and all that, helps cool it. Then we have the air to air, and it's all kind of one part, but it goes from that small, then it goes to a medium, into a larger, and then breaks off into smallers, and it does it again. And it's spaced the right way with the right little fins, the right areas to allow for pressure differentials, kind of similar, small, medium, large, back to small, medium, large, and it goes through relatively unabated, but then the right diaphragm and the right tension and so on. You get acoustics as they vibrate. They'll try and send most of the heat to where the air is passing and removing its boundary layer as efficiently as possible. But it still goes from that, large, a whole bunch of wide spots here, to back to the normal size. Back to atmospheric. We don't want to have to actually push more air than we should. There's still a fan. We still got the radiator for that, similar. It's just above and behind. So this is below, but it's not as thick for the air-to-air and water-to-air that's going on here. All really cool, compact, cool is what I say. Cool, quiet, yeah, okay, fine, I get it. Compact little design. There is no real big frame here. It's not a wide, it's just an arch, and a regular arch, and then standard triangle stuff, sort of thing. Yeah. But, engine fits just fine. It's horizontal. I got my rockets, otherwise known as injectors. And I've got my exhausts, which I can change the timing and the overall mount and so on. For lift is basically what that would be. Not so much duration, although I can kind of slightly change duration now because of this. Not too much, but, I can. So, there's that. That is the full package for $2K. You don't need a motorcycle license. You don't need insurance. Because it's only 49cc and it's a scooter. Like a ruckus. But it's you can go to higher RPM, you can go to higher pressures. You can go to a larger crankshaft if you really want to. Still 49cc, but it's those are the side crankshafts. Remember? And that's the plate. I can make a bigger plate there, and I can make a bigger plate there, and then it goes, as it goes out, it goes in, you get more torque. That's usually the worst part about that. You don't have a lot of torque. Well, now I have a lot of torque, and I've got a real good stroke. I can make this get really, really naughty, because I can still cool that turbine. And the coupler too, which of course is going to help out with the, especially as it cools, the exhaust, part, the little muffler, it cools, like produces electricity, yep, but it'll have to join in. Which means by the time it's cold, no longer do I have to worry about the air burning, no nitric oxide emission problems. It's a whole package. You cannot run it without this. Well, technically you can, but you're not supposed to. So now it's all emissions legal. Just add more fuel. Add more air. And the injector does both, for what it's worth, together. You get the picture. Anyways, that is, for 2K, all of the stuff. Big honka beluga power. Which, technically speaking, 50, well, you think it's high. It can be low. It can be low. Because there's nothing saying I can't go above, oh, it's only 9K. Which I'm like, this goes to 12, whatever. But it's easy to go immediately above that. Comes out that way, but nobody ever really does that because that's low eco, whatever you want to call it. Yeah, like you can pump out around to actually get somewhere, right? You want to go to 50K? You want the bigger crankshaft? You want some more torques? Let's get some more torques, some pressures. Alrighty. It's fun being me sometimes, Because, like, for what it's worth, it's like, it totally works. Remember those plates I talked about? You can't use them for the electrostatic, electromagnetic motor thing that I talked about. But, what I can do is I can add that before the transmission. I don't give you a transmission. But you can add whatever transmission you want. You don't need venerators. Although I've already come up with a multi-venerator setup, for what it's worth, with a middle venerator. So it's like, it goes up to this, and you're the one that changes the venerators and the air. And it's like, so it doesn't grab the clutch until you decide. And then it has the axle that goes to the rear. With a simple axle and some bearings and other venerators in the middle, and a couple more venerators along the side, you can change the gearing pretty easily. From wide to small, then that goes over to that, and then slowly, and then I can change that, and I can change this, I can change, And you have a gearbox venerator. Do you want it? Okay, sure. Nothing stops that from being good enough. But I like the thing Robert Murray Smith did for like this circle, like was it like a toroidal donut, kind of similar to the venerator, but it's you can change the gear ratios based on these circles, and then you can put them in a pack, and it's perfect for something like this. Small, short, compact, goes directly to whatever gear teeth that you want, or another version, same thing. Hydraulic fluid, you got it. You got electricity. Dum, 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 dum. You can change it. And you can change up to lower, and over here up to lower. So you got your standard bike, up, down, on both sides. And you got your gear brakes. Or I'm sorry, not gear brakes. Brake brakes. Not gear brakes. Although you wouldn't want to. I suppose you could do that though. No traction control really technically exists here. But there's generators, so don't worry. Which means changing gear ratios, CVTs. But they're gear CVTs, so that means they'll feel a lot better. And you can change packs, so it's like you'll actually feel gear shifts. It feels better. And you're more often than not in the correct gearing and RPM for you to have better gas mileage and torque applied to the wheels. Nothing goes to the front. I wanted to. I just didn't. There's nothing that says that I can't do it, for what it's worth. It's just I just didn't. What about the thing? There's a couple of schools of thought. So there's belts, there's chains, there's fluid, so on. You got the frame, you got the knot frame. Yeah, it depends on what you want to do. You know what I mean? But then you have to go around, and you have to go have that along the side of the yoke. And then you have to have that transfer it to the wheel. It has to move. It has to be reliable. I don't know. Two-wheel drive can be very fun. It's not bad. You will accelerate better. I just didn't do it. I mean, it's a 49cc. You can go all the way up to a ridiculous horsepower. That's something that caught my throat. It's probably my own hair. My hair is getting long. Anyways, but you can do it. I didn't do it. I suppose I'll sell you for like $300. Here's an add-on pack. Just bolt it on or whatever, and then you got front-wheel drive as well as your rear. There you go. But you have high-performance motorcycle brakes. You have a brand new transmission. An amazing engine and cooler and compressor, turbine, muffler. Jeez, what don't you have? Okay, what about like the different gear? That's different. It's still $1,000. Really? Yeah. This is 9,900. You know what I mean? 990. You know. This is 1,020. This is 1,200. Goes up to 2,500 because you want to go Formula 1 level. Engine block with all the special shit. Turbine with all the special shit. All the things with all the special shit. Even the frame is like, oh, you think I don't want the special shit for the frame? Let's do the frame special shit. Alright. Frame's fucking $2,500 again. Fucking jeez. Why? In the ever fucking... Really? Wow. Because you can do that? Yeah, it's not that hard. Well, I mean, kind of. I'd have to actually build the damn thing, you know, from the ground up. You know what I mean? It's like it's meant to be built for that. Like that would be the business. That would be like it's a good way to put it. I got a whole bunch of material. I had 3D printer. This thing. It's all for that. I was like, since I made it, so that way I invested initially really large amounts of money, I can then manufacture it pretty cheaply and sell it at that price. People would want it quite a bit. Obviously, I'd probably do well. I could sell for that kind of number. It's good. Look at me. Well, it comes out more like. Well, although it gets turned into a chirp with the muffler thing. It's a whole thing. It's more like a. Like like that. Which people like. Versus although it's one in the center and then two on the outside. So it's kind of a weird one, you know, when you think about that. You know, it's like boom, 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 boom. Like a lot of that. Anyways. So, there you go. That's what that would be. That was fun. Just decided to do it in the shower. I actually kind of talked about it in the past for a couple weeks in my head before I decided, I'll tell you about it here and all the rest of it. Well, you know, you're here. So it's like, that's what that would be. For that kind of engine sort of thing. Why don't you use the axle stuff? Oh, with the gears and the bump stops? It just doesn't work very well for those. For it's worth. It can work, though. The sliding part, you don't even need the thing that I have for the sliding part. But it's like, if I do it that way, then I get the air pump. Get the undulational air pump thing. Alongside of the oil pump. So it's like, that works. That's an easy, fast, compact. It works. There's a lot more stress and strain spread throughout the entire design. Makes it more robust, reliable, all the rest. Wow. You would not have that much horsepower and torque. What's your RPM? Or your PSIs? What's your crankshaft size plate? You got the torque, you got this, you got that. I suppose I can just dump all that electricity into this electromagnetic motor I've got. I suppose I should add that. Let's go do that. You got all this electricity being made anyways as I ride along. Capturing it, you know. Alright, so I still got the stator. I still have the electric stator thing. I got my batteries too, might as well. Oh yeah, I didn't sell you that for the capacitor battery things. I figured you just buy your own. Does it say batteries? That's where the placement of the battery goes. Got your battery area there. Oh, right. Okay, yeah. Anyways. So, let's do all the things and... Okay, fuck off. For how long? Just look at these battery failures. Full beans, 100% is 30 minutes of travel. That's your Delta V. I am at, well, I'm using rockets, so the flow and the thing, and so I just bump up the pressures. Increase the rocket exhaust injector things. I'm cooling the turbine and all that, you know, like emissions are legal stuff. Okay. So 250, I guess, about foot-pounds of torque. It's 5,300 RPM. Let's just take a look at some of the rest of this. Fuel tank is 30 minutes. Maximum RPM that I would want to technically speaking, you know, it's fully balanced. I suppose I can hit that 50k. Fuck it, let's go for a broke. Let's do that 62. It's kind of maxing out. For about 30 minutes, whatever that works out to be. This is the size of the tires. They are 33 inches. Because I wanted them to be lightweight and really fun. Oh, they have very large sidewall. Not that large. Jeez. New. They're wide, but they ain't wider than like 3 inches. There were 4.5 inch sidewall. The bigger ones, yeah. That's what it maxes out at. Standard 3 inch sides. It's a fighting garage. I didn't know how far you traveled. Okay, fine. How far let's see how far we travel. Let's see gear ratio, have packs of gears. Multiple packs of bigger to bigger. From the smallest to one to like massive. Let's just throw a fucking number out. That's the actual fucking largest I can probably get into this. 11.27 to 1. Okay, 11.27 to 1. Alright, that's something. Alright, so how far do you think I traveled? Let me just get that torque or horsepower calculator thing. I fucking saved as a bookmark. Let's just do that real quick. Let's see, bookmarks. Mobile bookmarks. Should be something. Google? No. Instructions? There it is. So what is it? Actual foot pounds. 251.2. Okay, engine RPM was 62. 62,357. 2,982.5 horses. That turbine is nice. Yeah, that turbine's very good. You adding anything? No, can't do that. It's the rocket. I can keep adding more and more. If I time it the right way, especially. Who says I can't just like, oh, here's some more pressures, here's some more pressures, here's some more... Let me just slightly bleed that. It's so much pressure at this fucking... Holy wow, yeah. Yeah. So let me just shrink it down, time it a little offset. And yeah, I'll just maintain higher heats and pressures inside of my cylinder, and I'll be able to cool it. Let's just bleed it off. I still have this. It's higher pressure over here. Now it's lower pressure over there. Now it's higher pressure over there. Now it's lower pressure over here. There's no way you could fucking shut up. Can you stop blowing me out of the water with my... Fuck off. Dude, almost 3,000 horsepower, practically. You don't know that? Yeah, I would never fucking go that far or my RPM. But I could do it. I have like a fucking 30-gallon gas tank I give you. No! Actually. Oh, yeah. Anyways. But yeah, no, like, that's... Like, because it's just an arch. And then it has, like, at the end, and then it's split. And then it has the line across. And then it has the arch underneath. And I have to have, like, that wrap around with the, you know, and then the front, and that's the, you know, the shroud stuff for the bike cream. Sorry, that's the radiator, the thing, and that's the down, the out, right? Right, and then kind of like the circle with the triangle, with the line through it. But it's not. It's a line, kind of, but it's more like arches heading inward with the flat part with the arch downward towards the down, and then it's arched, and then it's from there, because that's where the connect point, 3-part connect point is. For the arch, from the arch at the top, and then that goes over and arches, kind of like, you know, circle, like a belly, you know, right? Yeah. And it's like, this is where you'll have your engine. It's where you'll have your big, ginormous 30-gallon gas tank. The top, which is structural, by the way. So there's that. Is it? Well, I mean, it's pretty decent, strong aluminum. It's a ceramic, plastic. Shh! Stop. Don't. It's a multi-ceramic, rubber, plastic, and metal composite. And there's a fairly decently thick sidewall, and it's got the ribbing. It's extruded out that way. I was like, what does it mean? It means it weighs less, but it's way stiffer and stronger. And it has a decently thick, because it's ribbed, you know, it's got the little, as it's extruded, it's got the vertical fluting in the inside. But it's like, then it has like another part that we put in there. Alright, so another tube. It's like, why would you do that? Pretty simple. I have to have the vacuum. Makes it a lot easier to seal. You could also put batteries there. I don't. But you could, but I don't. What do you put there? Fluid. Air. Stirling. In, out, in, out, in, out. Gas, difference, pressure, heat, this, that, all that. What do you know? Piezoelectrics. Electricity generated. Sharp spring system. And the same thing with the rest of the frame, is basically the same stuff. How do you make this? So you know, like plates are ceramic, right? Yeah. Alright, so like plastics, certain plastics here are pretty high heat plastics, alright? They're really good at it. But some of them, obviously, you don't really want them to be around certain things. So you add in rubber, alright, then they'll suddenly be around those things much easier. But they don't really stick unless you got something that's a little bit more sticky. If you have the right metals, like an iron, aluminum, this is mostly iron, in no way whatsoever. Shut up, don't interrupt. It's zirconium, aluminum, boron, and carbon, of all things. And why would you? Carbon's sticky. Zirconium's good at being stuck. A little aluminum, stick it around in some heat and pressure. Then you, as a vacuum area for the extrusion process, squeeze, 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 undulate, undulate, undulate. What do you know? Comes out like a big old dookie, if I'm honest. Anyways, it does happen to have an enormously good tensile, compressive, lots of different strengths if I'm honest, but it's much lighter weight. Far, far lighter weight. Well, granted, I didn't give you the ceramics. I gave you some of the... I didn't tell you the plastics. I didn't tell you anything. But you know how to work it out, I'm betting. Because that's the creative process. And you know, me, what are ceramics? What's ceramics? You know, plates? I got plates in there. Certain types of plates. Get the right types of plates, if they're in there. Powdery. Waiting to be turned into something. Put it in perspective, for this one, it's like, I don't really want to tell you. Like, these are forever chemicals I'm putting into this, if I'm being really fucking honest. They're not, like, Teflon things. They're stuff I got from environmental cleanup. I was like, well, I might as well reuse this. So, I'll burn them. Yeah, fuck it. Screw burning them. Certain places. Plates? Not places. Certain plates. Perfect. They've been used ubiquitously for way too long. You add in the right extras. Rubbers? Look at this. What is that? It's asphalt. Look a little closer, bro. Okay, so it's got some tire rubber compound. Yeah, there we go. We're getting there. Get the right carbon. All right, let's talk about this. Carbon. What's carbon? What's carbon? It's an element. Yeah, obviously. No, I don't need graphite. I don't need this. I don't need that. What's cheap? What's ubiquitous? What's everywhere? There's a... Okay. It's okay. It sounds like I'm trying to give you something, and I don't need to tell you. Is what you go with. Meanwhile, me looking at a whole bunch of kitchen plastics that are high heat enough to go onto hot pans. Same thing with other rubbers that do similar things. Certain clear sort of plates and microwaves and other stuff that is pretty good at being able to handle heat. You catching it? Are you catching it yet? So yeah, kind of combative when someone asks me. So you should know this stuff to a degree. I don't need to explain myself to you. You're tasking me to give you legitimate, like, this should be patented shit. And I should just tell you? Okay, well, it should be patented. The SMI guy that doesn't have an income? You need to know. I don't think you do a lot of work. I think you're trying to steal some shit. Trying to sell it, pass the buck, as if you made something special, as if you did the work. You didn't. Now, moving on. So we're not done. It's like, those are some of the rubbers, some of the plastics. You can mix and match. You got a lot of different other plastics and rubbers. But those will work. There's some plates in there, sure, yeah. But we're not done. You have to have actually decent ceramics for this. That aren't just brittle and hard and can handle densities and stretch when you have the right ratios. Heat them, apply pressure, vacuum, cool. You get it. This is not going to cool in a vacuum. IR admittance. Certain reflection. Over time, it'll temper. Cool rapidly in certain places. And then have that go back in. Heating, cooling, standard ceramic process. Okay. We don't need oils. Now what's carbon that's ubiquitous? Where is it everywhere? You got it. Off the coast. What? Yeah, you got it. Bingo bongo. Oil spills everywhere. Garbage, diesel, all this crap. Clean it up. Use some charge field differences like the MIT people at their Sukis. Desalinator. What do you know? Works out. Grab the oils. That's my carbon. The hydrogens. Yeah, I'll use them for energy generation or something. Yeah, my carbons though. Whatever. Really? Yeah, pretty much. Not quite done, because I'm in a city. Let's say I was in New York City. There's a lot of carbon, claggy, smoggy crud all throughout every fucking building. Every piece of shit, goddamn sidewalk, door, everywhere. Ugh. Somebody needs to clean this up. Some nice carbon. Hey, remember those vacuums? Brrr! Same thing. A little light, a little bit more vibration. Bingo bongo. Cleans it up. Gets me carbon. Okay, we're done. With carbon. Right? No. We're not done. I don't have graphene. I don't need graphene. You have graphite. I don't want graphite. What do you want? I'll have rubber up bits of road, tire compounds, which have different things in them. Yeah. Hey, so, what if I put a bunch of graphite particles? I don't need to be nano size. Varying sizes and shape. Alright, now we have ceramic that we're actually going to talk about. Everything so far has been glass. Glass is not really quite what ceramic is, even though it is technically a ceramic. But it's not. So what do you think I'm going to be using? Honestly, I don't know. It's okay. This is pretty ubiquitous. Ceramic. It's very, very common. What kind of ceramic would be common? Ceramic's everywhere, truthfully. But okay. That's why they paused. It was like, no, there's no. Okay. Yeah, so where would you look for ceramic? Look at them looking for an answer here. Okay. You have an answer? It's not quite the right answer, but close. But you guessed it. The stove! Electric burners! They have ceramic on them and iron inside. There's your ceramic. Done. That's the ceramic. With the glass. And the plates. The little zirconium. I have these nanoparticles. Various sizes and shapes. I have this round rolled up rubber garbage. Well, yeah. I'm not done yet. Remember was this aluminum? A little bit of iron, because of course it's going to get in there. Heat it up. Put it under pressure. Vibrate it and extrude it into a vacuum. Heat. Expand. Slow. Cool. So on. Yeah, here's the thing. You have some plastic. Why? With metal and it makes it a little bit more flexible. It absorbs a lot of impact. It's insane tensile strength. It's great density. Incredible compressive loads. Its hardness is pretty decent for what it's worth. It's not a diamond, but still. It's still pretty darn hard. It's basically just a metamaterial, but it's not really. It's a regular ass material. That's all it is. It's an alloy material, like any other. Here's a couple elements struck together. Struck? You mean put together, like in a mix of a pot that's warm and gooey? Yeah, basically, we pour it and then it's good. Okay. Warm and gooey, environment is a vacuum and pressure differential. Squeezes it as it goes through size for extrusion. Heat, warm, cool, hot. Aligning particles. It's like an alloy forge welding tempering process. Or an extrusion process. So, we're done on that. Standard aluminum. Now, what's the actual biggest thickness for that point? Oh, right, but these are big, long sine wave, with a curved tip, just so we know. So, big, long, elongated. I want you to really know it's elongated, okay? Its thinnest is a millimeter. Its thickest is a 1/4 inch. Then I have a tube on the inside. It's a hypertectic aluminum extrusion. It's 5 millimeters thick. That's it. Okay. That's it. That's all you need. It'll squeeze inward, bend a little. Well, yeah. Jeez. Why the hell would you only have it a millimeter thick at the fucking... Would you want it a little thicker? No. I want it to bend a little. I don't have any ribbing. It's just extruded. It's very vertical. All vertical. Ah, finally. Someone asked. Well, let's go with the diameter because then you can understand slope angle. The full outer diameter. Wait for this one. It's only 1.75 inch. 1.75 inch. 1.75 inch. You should be able to find the slope angle for a millimeter to a 1/4 inch. Why conversion? Well, I wonder why. Maybe you'll figure out that conversion difference and why it looks like that with an 1.75 inch. It's a little more vertical than you think. How many inside? Because you didn't say that. Smart people. I like them. I like smart people. That's a good question. Thank you. No, it is. 12. I have exactly 12. It works fairly well. Fucking 12 of these? Quite vertical. Like I said. But it'll shrink out, twist. There's a great decent degree of torque. Remember that? Yeah. You know how the circle things work with the thing in the inside and it has to go out to end and longer, shorter, all that? I didn't think so. the ring circle. Oh, but it has a gear in the end, and that's the cone gear. That's how that works usually. You can change from one singular point or two. And you can have bigger and different gear ratios. Because they can magically, somehow, I don't know, it's magic. Wow. Connect them with different angles. And have it here off the side, then they can go over, almost like a right angle. And you have that go from that to a beehive. And then off to another right angle. Which then can go over and do another beehive. Which can then go over into, of course, the other beehive. But this was a beehive and a beehive. So really it's just a, by the way, beehive in this instance is a cone pyramid, essentially funnel. So we're moving on. But it's like, that's an hourglass, but they have an hourglass into an hourglass. They bisect. That's the axle gearing. You have to have a chain. Oh, why do I not use a chain? I can be cool. I can have an axle. Can't I? What's wrong with having an axle? How would you do an axle? This one's fine. I have worked my butt off on this one and I threw it out. So don't worry. I'm not even kidding. Like, literally ignore this, but start thinking about the process, if you want to, from this. So, this is a multi-material axle. You remember, like, spring steel, there's torsion, gull wing stuff? Remember that? Yeah? Yeah, similar. Take elongated strips. In this instance, it's like fiberglass. This is ceramic fiberglass, rubber, basically. It has ruffles, waves, horizontal. So if you look at it as a long rod, horizontally instead of along the length of the rod. Okay, you have little waves. And then on those little waves you have sine waves, like gears, but they're not gear teeth. Okay, wait. Then, on that, there's along the length a bunch of, that's right, channels, grooves cut in to the length. Oh. Then there's multiple, 6 with 1 in the center. They're in a pack. They have these little things that hold them together, but then they can torsion. They're attached at the ends, of course, and then they torsion. Once torsioned, well, they can flex, but they'll flex a lot less. They can move up and down with the gears. They'll rotate accordingly like an axle. I have an axle. Then I put it with, oh my god, the craziest thing. You know these CVT belts? They have multiple steel parts that slide on each other. They're fairly tough. Well, you know what? If I put that with a cylinder, a couple cylinders like that, they can stretch and bend. But guess what? That's how I first started this idea of this axle. It's a flexible axle that can put a lot, and I mean a good damn lot, of torque and horsepower. I then got rid of it. Remember I told you that? I was like, well, why do I have this? Multiple steel little tiny pipes will do it. They'll still spin. They'll still flex. Needs a vacuum. They have strain and stress on it. The right seals. There's a couple pipes inside of a pipe. Some sealing. Moves, undulates. Rotates pretty well. It's pretty small too. Pretty good at doing it. Turns out if you stretch it a little, what do you know? It's an axle. All of that work. Just do this. Weighs less, lasts longer. Throw some oil on it every so often. Done. It's an axle now. Just stretch it a little bit and boom, it's an axle. Okay, so that's cool. That's an axle. All right. All right, back to my gear pack. And then, oh yeah, no, you already know how that works. That's right, for my rear wheel. Woohoo! Yeah! Woo! Yeah! Woo! Yeah! Oh, guess what my rims are made out of? Basically another version of the fucking thing the frame's made out of. You know how this tube works? This tube works, goes in, it's got a vacuum in the center of the tube, and then there's tubes on the other side, and then the thing where it's connected, and there's vacuums there, and the vacuum T-joint there, and that thing, and then tubes and so on. You get the picture. That's a bunch of tubes resisting any direction change because vacuum. Guess what? It's insanely lightweight. That's right. And it happens to absorb a good amount of impact. Because they can only really move anything for where the tubes are and where they're connected. Which means, ooh, man, I can really put good seals on that. Look at these diaphragms. They're piezoelectric. That's a generator. Same thing with, you guessed it, the shocks and springs. So you know about that. That's lighter weight. Way lighter weight. Because guess what? I have an internal. I didn't do this before. But, so you remember the bead lock thing? You know, it's like 3.5 to 4.5. Standard 3 inches. Yeah. Right? Yeah. There's an internal, it's not a tube, it's airless. It's a structure. Okay, well, why? It's not for punctures. It's actually something that you hook on to the rim and you don't have to have it. It's got piezoelectrics. You are correct. As it deforms, you can use less pressure. Deforms more. It's softer. I can use less pressure for spring. It happens to get more grip. It's pretty decent, if I'm being honest. And I am. It's still being able to provide puncture protection. So there you go. Works out. You have more electricity for rolling around. Now, granted, it takes a degree. Well, I mean, you're already gonna. Right? Now, they'll go down to as small as 28 inches. Standard's 33. There's nothing bigger. And that's the bike frame for $1,000. With the rims and with the tires. And, of course, the brakes. Ariane, and the squeezy hydraulic ram, and then the changey geary things. I already set up, if you want them. We recommend a certain transmission we make. What do you know? It's $1,200. Oh, I gotta have this. $300 to get you the front wheel combo too. Even $1,500 there. That's an easy sell, right? You're already going all in, right? You got $1,000 for the engine. You got $1,000 for the back frame, of course. $1,200. I might as well have front-wheel drive. It's only $300. No, I'm told $3,500. It's cheaper than any bike that you'll ever have, and it'll be better in all ways. And you can even change the acoustics that come out. Nice, right? Finger pistols. Woohoo! Yay! Right? Yeah, now here's some batteries if you want some batteries. Comes with the tank, right? Yeah, no, the tank has this little thing that you bolt. Well, not bolt. You slide on it, and then you still have to bolt, but it's like, yeah. It's kind of like a tension thing. Yeah, there's a little string tension thing that goes through, but then also there's little tubes that you put in, and that's also how you bolt some stuff. There's gasket, all that. You can hide the fuel through that if you wanted to. I don't. But if you wanted to, you could. I've seen it modified that way. It's pretty easy, but I don't. Big, fat honkos, tubes. This is what you get with it. But it goes down to the archy triangle and then the inward triangle flat part. But that one's just flat. Yeah, exactly. Yeah. Oh, so it's kind of like a soft. Oh, it rotates up. Oh, it's not up. Flat part. Because the flat part, because you have this part that connects in the rear, that can go up and down. That can go in and out. Because it's connected with. Ooh, cables! You got me already. You know. You know I like my suspension cables and pulleys. Guess what? It works. A little bearing, a little lube, and what do you know? Softail. There's vacuums. Spring tension. Air on the outside, some holes for the tubes. You get it. Guess what? There's basically no rust. It's pretty hard to make this thing rust. You have to get really hot, and you have to leave it in a very high oxygen environment with a lot of water and salt. I think anything will rust from that. That's fair, yeah. So, that works well enough-ish, I felt, for a solid 1K. You get tires, you get brakes, shocks, springs, one of a kind, suspension, all the things, man. Now these batteries, how much do they cost? It's about $3 to $1,200, depending on what size you're looking for and all that. Yeah, I know. It's like, so do you want the, what is this, the 1,000 kilowatt hours? Or do you want the 100,000 kilowatt hour? And that's the 300 to 1,200. That's my capacitors, there's the batteries, there's the circuits, and so on and so on. $700 then. Okay, let's go. Oh, you talked about it earlier. I know. Ah, fuck. God. Yeah, they're all 100 for that 100,000 watt. But you know, capacitors around because you're rectangle and then series with parallel, blah 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 blah, battery, blah 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 blah, and so on. Why do you do this? Why? Oh, there's area underneath, there's area behind and underneath your seat. There's your radiator, the front, there's your transmission. It can be covered by batteries, but you know, air still gets to it. Doesn't really heat up much, but you know, whatever. And here, the area behind your seat, where the wheel is too, it's gonna go up and down. Look at that. That's why it's a circle. See this? This is really cool. That's the reason why it's a soft tail. It's kind of like a, well, it's more of an oval crescent moon circle thing. You said like all the thing, yeah, because it's all those. Remember, rocker arm, pivot here, that crescent moon goes down there. Remember, circle, it goes up, it goes down like an oval. Suspension! Bearings! It fails less. It's sealed now. There you go. Same thing with the front. It's kind of a similar design. Good old springs and pulleys. Yeah, pretty much. Yeah, it works. Alright, so, now, $1,200. You want the 100,000, so you wanted that. 3,500, you're already in. $1,200. Is it around to again? 35, I'm bad at math. So someone said 12, 4, $4,700, huh? Still lower cost than most. I still got you a very capable, insanely good, if I'm being honest, way too high torque, way too high horsepower. $49cc, don't need motorcycle license, don't need insurance. Bicycle. There's no pedals though, so have fun. This is a scooter, right? Yeah, something like that. Yeah, a scooter. Yeah. It's gonna be fun. See the axle? See the motor? Electricity. Oh yeah, no, that's true. Yeah. Oh, you have an axle, like electric motor? Yeah, well, that's radial apparently instead of axle, which is weird. But it's electrostatic, electromagnetic. Same thing with the one in between the transmission. What's that? Well, okay, well, yeah. Why? Dynamic. What? And apply it directly to the wheel or through a given torque multiplier or RPM multiplier. It's a little more dynamic. It's kind of like torque vectoring to a degree too. It's like that. You can split off to the front because you want the 300, remember? Right, yeah, well that goes up. In this instance, it's a tube. It's a relatively decently not tube. Why would you say it's a tube but it's not? Yeah. Yes. Why would I say it's a tube but not a tube? Really? Are you really doing that? Yep. Remember a tube can stretch and bend and all that? It's like a belt, you know? Well yeah. Yeah, you know, you can get around certain constraints if you do it the right way. So it's like, look, here's a pulley or axle, whatever, and it has to grip that. Sure, whatever. I guess if you want to be lame. But think think about this. Let's stretch cloth. Let's stretch like the rubber band, you know, the physical therapy rubber band stuff that you have to bend, you know. The bends, alright? So it's like, you got that, that's the tube. Imagine it's the tube. Well, if you spin it the right way, it'll curve over here, and it'll stretch over here. It'll stretch over here. Now it's a weird oval, but like these parts, they're not really stretching. It's a weird oval diagonal thing. Now, if you have that in your head, and you can imagine and picture it, what could you do with something like that? Seriously, what can you do? Well, it's a sealed system. It hangs off the side. I have to bolt it on, all that stuff. Well, I mean, you're going to have the axle there. It has to go in, it has to go out. It has to go up, it has to go down. It has to go do this, that, and so on. So clearly, the tube can do that. That's right, the yoke. Which is what I imagined you were talking about for the axle. So yes, you are correct. But it has to go from the transmission up to the yoke. How does that happen? Plus it has to do it and transfer it in such a way that's very well done. Meaning low loss. I hate loss. Loss sucks. So how do I do that? Yeah, I love the thinking. Thank you. Really? Yeah, seriously. You have no idea. It bothers the hell out of me that nobody even tries to think about it for themselves. I did this all myself. By myself. No one fucking really helped me. Not really. I brute forced this back in my Chandler house my parents had when I was there. It's not my Chandler house. So it was my parents' Chandler house, but you get a picture. What is the straight axle? Ooh, a straight axle would be nice. I suppose it could work. Does anybody see a problem? Boom, boom, boom. Goes up and down, side to side. Takes a lot of strain and stress on those little points where it's connected. That's true. Yep. Alright, so we're going to move forward. Okay, we can have a straight axle. It's clear. You use that axle? No. This is why I asked. You know, you use multiple gears. Nope. What did you do? Vacuum system in this instance. A vacuum axle. Eee, woo, calm down. Oof. Jeez, I can feel the tension already. Tension. Remember? It works for my, what is this, tire? Yeah. Okay, so a tube within a tube. No, you know, gear. So there's a gear with a vacuum. With a tube around it. It rotates, does this. How does it transfer its energy? You can't transfer, right? It's a vacuum. There's tension. That's what that would be. You got it. Rotates one way, puts tension the other way. I have a vacuum belt. Just gotta have the right little spaces and so on. Now I have spring tension. They never really touch though. There's a tube there, but it can bend, it can move. Because bending and moving tubes that are sealed, well, we already have an axle that's doing that. Pour some oil every so often. Well, you know, works. Guess what? Similar system in this instance. More of an Archimedes screw vacuum. Remember the belt thing I talked about? Well, what can you imagine? It needs to do all the... Oh, well, yeah. Go in, go out, go outside, all the rest. Inside of tube. I have an axle, vacuum axle, tube. The Archimedes screw spins, rotates into the gears with the electric motor and all the rest of that. So, God, thanks, man. I worked really hard on this. I was hoping for a response. It's like, well, if I can make fucking tube vacuum stuff, why can't I do fucking chains and all the rest of it? Let's go. That's literally me. Let's do it! Weighs a hell of a lot less, a lot more flexible. Transfers energy really fucking fast and well. You just gotta do it right. Guess what? It's really easy to put back together and take it apart. It's gonna suck air out, which is kind of the main kind of issue, but whatever. You get it come all together one package. Well, you gotta put the wheels on, put the engine in. It's actually a couple packages, but you get the picture. Right. Amazon workers, I'm sorry. This is on Amazon. UPS and more, I'm sorry. Yes, but it's very lightweight. It's very easy to pack it, but it's okay. I swear it's not that heavy, but it does suck. Oh, great. Yep, no. Dual drive! Oh, yeah! Transfers energy so well. I don't have as much friction as you. I have way less weight too. I make lots of power. Look at my power. So much fucking power and torque. My RPMs are off the charts. Did we get the 25? We got the 1200. Oh, okay. Well, that's gonna change. That's 4900 then. That's true, yeah. Woohoo! Fucking still under $5,000. I can't even buy a used motorcycle for some of that shit. That kind of performance? Are you kidding me? It's not a motorcycle. Remember, it's just a regular scooter. It's just a regular scooter. No, it's supposed to squat forward. So it'll squat forward first, then it'll go flat, and then it'll lift it up. It's supposed to do that as it loads. And that way you have all your traction as much as I can. Well, you also have the changing gear system packs that's going on there. So that way you don't die. It's kind of like traction control, but it's not quite like traction control, you know what I mean? Why? I like wheelies. Are you sure? I can easily do that. The amount of torque drop that I can frickin' push on this. If you've ever had those moments, which I haven't, and I don't want to, then you know why I did that. Maximum acceleration! There's the recumbent one, sir. Oh, yeah. Thanks for reminding me. Same thing. Lean back. Kind of. It's not monkey, but it's like they're back. They're further, right? And a nice, longer padded seat in there, so that way it goes to your back. So, like, that's nice, you know? Yeah, that's good. Yeah. Put your legs up. Enjoy. They're still huge tires. Yeah. Yeah, they are. I have the torque. I just don't care. Smart surface area, more generation. I don't know, man. What do you want from me? They look aesthetically cooler. That's why. that's why you have the beadlock thing. Yeah, because it has tread along the side, so you can get more turn. I mean, more angle, because like there's basically nothing there stopping you from really giving it some turn. Come on, Jaden. Phil, holy jeez, it's terrifying. Just massive angle, yeah. But you'll make it. You'll make the turn. That's why it's got the fucking wow, yeah. Okay. Nice. So, what is this? Oh, it's $4,900 all in, all the things. God damn. It has a trailer hitch. Here's my trailer for $2,500 here. It's a composite. Yes, no it is. So, it is canvas impregnated with epoxy in strips, specifically. Tensioned. Not with fiberglass though. We're going to use regular synthetic. I keep losing my cell data. I don't know whether that's important in any way. It keeps telling me. Anyways. They're, able to be in these tubes and torque them down. Okay? So then they slide, tube within tube, slide, latch, twist nuts, they lock in place. Yeah. So, then you have the spring tension of the synthetic fibers that are really good at handling very high loads and tensile strengths. Talked about a little bit of it before, but this is slightly different because there's layer with layer like the camp thing that I talked about with my van. So, anyways, camper van that is. Similar kind of thought, but it's meant to slide out and become very rigid, very tense, and insulative. It's very lightweight. Most of the weight is down low where the batteries are. Because, that's right, the top has solar panels. It's got a AC, quotation marks. This one is a phase change dual Thomson acoustic pump again. They're really good, honestly. But this one's the rotating version altogether in one. Like the turbine, the turbo, the jet engine. Well, if you do it right, well, guess what happens? It goes through a jet-like style as it rotates. Jules Thomson phase change of pressure, and evacuates the heat along the, you guessed it, the shroud, the housing. There's stators with inside. It needs lubricant anyways. And what do you know? What would you have it? There's heat sink fins on the outside. There's also IR maintenance. Because, well, it's got to be sitting on something, so why not? Here's an IR emitter. What's my phase change? This one's salt water. So, as brine solution goes up, vortex, phase change, blah, blah, blah. It's a whole thing. Gets denser. It goes under, it goes. Pressure changes back into vapor. Salt helps condense, goes back to cold. Concentrate during this, that, you get the picture. Not really. Let's do this one more time. Okay, fine. I want to get this done already. We'll go to bed. It's fucking over midnight for me. 12:51 p. Oh, sorry, a.m. a.m., yeah. Okay, so, brine solution. There's not very briny, where it's doing its phase change and it's changing its pressure and evaporating. But because there's salt there and because there's a, well, manifold vortex inducing kind of thing, which isn't really a good way to put that, but it's essentially what that is. It's the Jules Thomson version of a acoustic pump phase change pressure difference vortex thing. So it spins, changes pressures, goes faster, changes to eventually, guess what? Vapor. Big old tubes. Not really though. It's small. It's small stuff. I don't want really big ones. And so, air. And how does air work? Well, if it vibrates, it undulates the right way. Air moves one way. If you put them in the right stack, vibrate, vibrate, vibrate. Air pressure exchange, heat goes into phase change, condenses, concentrates. Brine concentrates there, goes into, of course, the brand new jet engine. In to out to in, small to medium to large, wide boy. You know about, I just talked about it. Brine, it's concentrated as it spins, acoustic, so on. That's where most of the salt and heat, really, truthfully, we're talking about it, can be dumped into and pushed through. With the water, phase change. It's coated with ceramics. It's okay. So it changes, exchanges heat to the outside of the housing, and then there's also the other elephant in the room, the thermal, the IR emittance part. Since this is already a pump, already know. I got more surface area, that's my radiator. Goes up, goes back down. Spin, spin, blah, 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 and concentrate. You get the whole picture. Very low energy, very high cooling. It also happens to run a wonderful refrigerator. It's not exactly a mini fridge, but it is a mini fridge. It's got frozen, it's got regular, but it lays down on the inside. Oh, at the bottom. Yep, there are 4 wheels. They have suspension like I talked about. The trailer has the same internal vacuum so-ons for spring and shock. There's camber. They'll turn together with you if you set it up with the right little connector. It's got the brake light and it's got brakes. They're all independent suspension. Independent suspension. If you want to, you can tie it to, with that little connector, your throttle. You'll just make sure it doesn't push. You'll be the one that doesn't really push, it just reduces. So it has batteries, yes. There's no gas tanks. Opens up, and there's a screen, there's insulation, you get the whole picture. On that side, this is $2,500. The only extras, if you want them, because that's a $1,500 option, yeah. So it's like, this is pop-out windmills and turbines that can also go underwater if you want to, or just be used as windmills. No heat exchanger this time. Sorry. And a bathroom portable. That's right. This is the one-pot method that I talked about to create hydrocarbons. This is added in. You have to take it out every time, but it's what it is. It works though. So that'd be $3,500. No, it's $2,500 and then $1,500. So if you want to do easy math, it'd be 2,000, 2,000, which will be $4,000. Okay, $4,000. 4,900, all told. Revolutionary. Okay, sure, yeah. Bike. It's a scooter. Scooter. Okay, so it's a scooter with a trailer. How big is this? Thank you. Finally. 12 feet by 18. Bullshit, not 18. Don't say that. 8 feet. 8 feet. So 12 feet long, 8 feet from that side to wheel, that side to other wheel. Depth totally, when fully out and about, 11 feet. Height. Granted, you're not getting that standing. You're getting 9.5 feet. You have a refrigerator. You need stoves. It does come with a stove. I didn't say that, but it does come with a stove. It comes with a sink. There's a bunch of other stuff for water and so on in there. If I'm being honest, it has a bunch of batteries hidden throughout all of it. For what it's worth, the tubes have batteries, the frame has batteries. The refrigerator is basically just batteries, and then it cools the inside. There's a what do you call it? Wicking effect? Yeah, wicking effect. Yeah. So it's like it has a little bit of a pump, and then it'll carry itself and keep it going. That's its pressure. It goes, and that's what you get. It's more efficient. But since you have to crank it anyways, with a button or a regular crank, that'll pull water up. Because kind of like vacuum and. So that works. Yeah, I know. What's your stove? Light on a very absorbing surface with electrical resistive heating. That's about it. With the whole top of the insides, where it's not covered by the solar panel, it concentrates light into the stove. Fiber optics lines the wall, and into the electrically resistive heating ceramic plate that happens to be absorbing a large amount of IR and all the rest of the natural and so on. You get it. It also happens to run your stove. But it also has a microwave in there for the stove with air that you can pump in that's electrically, kind of like a space heater. Sort of the same thing. Space heater, microwave, electricity, reflect, heats it up. We don't want microwaves to go too far, so it's mostly IR, reflective and emitting, but it's there to heat it up, start the process, get the oven to the right temperature. And there is no microwave, so you're going to have to suck that one up. But it can be used just off the microwave, so have fun. We got the big, and then one singular small. Yeah. We have the, wait for it, wall plug. That's right, it's a surge protector with a UPS to it. That is a total of 12 plugs. Have fun with that. I don't know what you need 12 plugs for, but okay. It also has USB, standard USB stuff. You have charging your phone, to charging your laptop, to charging your, if you decide to, because it has a trailer hitch to the trailer, which is for, that's right, an actual pedal bike e-bike that I have. Hybrid, more than anything. For like a 49cc. No. It's the turbine. You remember the turbine? You remember the it goes back, and it goes back, yeah. That's part of the frame. The spine. Then batteries underneath, and then batteries for where you sit. And then, where you put the sliding part in, for your seat. That's the batteries. battery. The frame is basically a battery. Yeah, pretty much, yeah. It doesn't need to handle as much hit, much. So it's like, it's a little thicker, it's about, it's thicker than your bike is going to be, but, whatever. Still has all the suspension and everything, but it's only electrostatic, electromagnetic, kinetic, and momentum amplifying motor. Is that just a generator? Not really. So it can go faster than 20. You can modify it to do that pretty easily. But no, and it has pedals. Big, ginormous differences to your pedal ideas that you think are good. I don't like a large amount of the pedal ideas that are out there. Still big, long cranks. But as it goes in, it slides, but it's on a rotating crank. And you remember the whole like axle with the bump stops and the gear T? Sort of similar idea. Rotates. It slides. Rotates. Crank goes down. Full duration down. Full turn. Transfer to vacuum chain, basically. Axle thing. Part of the frame, though. So that works. It's the electric motor, and only the rear. So you have an e-bike. Ah, yes, definitely. Oh, why wouldn't I? It's... Does it get hot? No. It gets hot over there, though. Where's there? Behind the wheel. Behind them. Because it is meant very much not to go fast, not to be mountain bike, to travel around and cruise. So it has a thing in the front to make sure no splashy splash to anything. And a rear one too. What do you know? That's a decent muffler design. No trailer though. Good basket, good saddles. You can put a trailer and a hitch and all that if you want to. Sure, go for it. I don't have a mini one. This is what I have. Okay, well, Do you have a small one? What about kids' groceries or something? Why don't you just drive your fucking bike to the grocery store? I'm camping! Oh, I'm camping, okay. Here's a fold-out one in the shuttles. Then it just hangs off that. Stick it on. Yeah, well, yes. No, you're gonna have to torque it, sure, yes. For what it's worth. Oh, slide out. Torque, bye. Done. Easy. Suspension. Nope. 4. There's 3, you said. There are 3, yes. That is an axle, the bendy thing, like a tail, and then 2 in the front. Slides up and down, works. It's good enough. Fucking jeez. So okay, all the slidey things and so on, with the fucking, okay, I get it, so that's probably what that would be. Yep. There's no tubes, they're tubeless. Same thing, if I'm gonna make them that way with those, I might as well have these ones with that. Same thing with the trailer. How big is that? 5 feet by 5 feet by 7 feet. It's a good thing it's mostly skin that gets very taut, and there's a few plates that of course help support the whole thing with suspension and all the rest. All the rest, there's not a membrane. No, I just said that there is. This is skin, taut, tight plates. Okay, I'm out. Fuck off. There you go. Here's your groceries. It's got suspension on the wheels. All of them. Very hard to puncture shit. You can still put saddlebags on there. Here's my battery pack. Comes standard. The $300 option. 1,000 kilowatt hours. So there's that. And then I have turbine. But there's a trailer. See what I mean about the trailer? Why would you want a trailer? I don't know. Is there any fucking thing that no, it goes up. It goes up and around it. Fucking and out. Fucking screw this bullshit. Here's an attachment, fine. Boom! Here's a fucking long tube off to the right or something, wherever. I don't care. Done! So done! Anyways, here's some pedals. Anybody want to talk about the fucking cranks and pedals? This is really good. This is 99% efficient, downward and upward. It clips, you know, you can hook your thing. There's a hook, like a strap. Oh, yeah, that kind of thing. Both. Yep, there you go. But you have a turbine. Oh, yes, no, I have a turbine. Where's the gas? That's a good question. Remember I said it wasn't very warm? Yeah. Ow. It would be very... Oh, so there's a structural fucking turbine, a part of your bike. It's not dangerous in any way. Okay, alright. Couldn't you not? Nope. Those are my battery areas, so... This is a fucking motorcycle? No. It's an e-bike. It's a hybrid e-bike. It can produce electricity, or it can technically be modified very, very easily. In fact, insanely fucking goddamn every way easy. There's an internal axle. This is actual top speed, 70%, 90 miles an hour, 250 pounds. Modified though. Cool, alright, let's go. Yeah, no. But see, that's the thing. It's just a regular e-bike. It's genuinely only meant for that. Remember, they curve. So it's like, that's where the batteries, and they have to curve. That's fine, because that's cruiser, but see? It's wide. Yes, finally someone remembered it's wide. Big frickin' hunkin' scoop. And here's the gas behind it. Where the exhaust is. That's so dangerous. Oh yeah, so safe. Motorcycles and bikes and so on. They're always so very safe. Every day, safest trade ever. But you got a basket in the front and a basket in the rear, and you just saddlebags. Here's your freaking thing, and so it goes off to the right or the left or whatever, wherever the hell you want. I don't give a fuck. It wouldn't get in the way anyways, for what it's worth. The thing's not gonna melt. It got warm at the front though. Yeah, but then you got the little thing. And here's a little rooster tail part. Pretty much, yeah. Point it up. Goes over. And here's a little extender. Because apparently you want it to be fully open. You don't want to just collapse it and then open it. So it's like, but you will use it for like groceries. It can be multiple stages of full open. It's structurally supported. Its full maximum is that. It can be pretty compact. Jeez. Yeah, anyways, but yeah, there you go. How much does that cost, all told? $2,500. Yeah. I don't know why the hell. We go camping. I gotta go back to the grocery store. What? Why don't you just go cruise around on my pedal bike? Jeez, fucking what? Anyways, but there you go. You can do that all together. 2,500, 4,000, 4,000, 4,900. There's gonna be some taxes, right? Yeah. But let's just rough it. So, 4,000, 4,900, 8,900, less than 9,000, then 2,500. So it's 9,000 and minus 100 because that's easy for me to do for some reason. 13,500, 13,400. 9 plus 5. 14, 9 plus 4. That's 11. Ah, there we go. Thank you. You caught it. He's around. He's being a dick whenever I do math. Okay, fine. I was... Oh, fuck. So. 2,500 is... 11,400. Alright, so you got it. You know, 11,400 for a bike, a fully featured camping trailer, another bike with a trailer. What's that range? About 500 miles. 500 miles. 90 miles to 140 miles an hour. Which the trailer can take, so. Full beans! Hey, that's what I need to do. 140 miles an hour. Alright, so anyways, $11,400. Of course, there's taxes and so on, so you probably under 15 even. Something like that, right? You know? Yeah, okay, alright. Come on down! Do you want, for that amount of money, to live by yourself with one hell of a fucking goddamn beast of a revolutionary scooter, trailer, bike, e-bike that is indeed, yes, thank you very much, with another trailer to get your groceries to your trailer. A smaller setup for your larger setup. Oh my gosh, oh naughty. Can you, yes you, picture yourself traveling along the countryside and enjoying the sights and sounds of our great nation, having all that you have to do whenever you want, of course, alongside of all the accoutrements inside of your house, inside of your trailer, really, because it's a trailer, but it's your house, though, if you're really being honest. It's got stove, it's got batteries, it's got a refrigerator, it's got a projector, it's got screens, it's got insulation, it's definitely got cooling and heating. It's got a sink for your dishes. It's got a cabinet for your dishes that you cleaned. Hopefully you dried and you cleaned them. Hopefully. Not in that order. Jeez. And that's right, you even have places for your clothes. Oh, you even have this thing called more power generation. Your bike can be a power generator if you so choose. You have windmills and turbines, great rivers if you want them to be your friendly power generating neighbor. Yes, they can do that too. Yes, that is right. If you want to add even more storage and or power, we well recommend some of our other options we sell. But I don't think you'll probably need it, if I'm being really honest. Your stove is heated by the very power of a nuclear fusion ball we orbit. The sun, but also electrically resistive heating. But you know, you got that electricity somehow, some way, and considering the sun is the thing that makes it so you have fossil fuels and everything else, you got it from the sun. There you go. Your batteries, you've got 500,000 kilowatt hours in this trailer. You got 100,000 kilowatt hours in this bike. You got 1,000 kilowatt hours in the e-bike. I'm sorry, not bike, it's a scooter. Oh no, scooters are so lame. You have 250 foot-pounds of torque and up to 6,200, my ass, 62,000 actually, RPM at your disposal. A quick calculation math means nearly 3,000 horses. That's right, to get those ponies going, let's go. You have a 30-gallon gas tank, that's right, for your scooter. It's a scooter. You will enjoy, I swear, your life on the road full of luxury, obviously. You've got your lovely refrigerator, you've got your storage, you've got your fun and games. There's a place to hook on your internet that you travel with. You can go cruising along on your e-bike. It's got pedals. It's an e-bike. If you maybe thought about going online and looking it up, a possibility of going faster than it's intended. It's a hybrid e-bike. Still has 1,000 kilowatt hours on it. It can generate electricity for you, but you know. Anyways, have fun, enjoy. All told, without the taxes, $11,400. That's right. The suspension and weight is definitely taken care of. The trailer itself actually adds, that's right, power. You still pull it along, but it reduces the weight you feel because, that's right, there are motors, electric motors on there that help it. It has suspension, 4 tires total. That's right. And so does the smaller trailer to your e-bike. Doesn't have electric motors, but it does have suspension. Stop trying to give me more work to do. I'm sure you can do that yourself. There are kits out there. That little trailer, oh man, wonderful little saddlebag looking like kind of thing, and then it can pop out all the way to a 5x5x7. 7 length, 5 height, 5 width. But it can go smaller than that, and this is an attachment that allows for you to have that exhaust if you were using it. Go around and not even touch that trailer. It has internal suspension, That's right, I did say that internal suspension. You see this? It's a vacuum. That's right, a vacuum axle. Vacuum chain. Vacuum suspension and shocks. Not just springs, shocks. How do you use vacuums for shocks? How do you use vacuum tension? That's right. Bring, bring. Yes, as I lose my connection to cell service. I don't give a fuck. Anyways. For the rims. That's right, I remembered. For the rims. The rims spokes for this scooter are vacuum tensioned. How did you do that? You made me want to buy it so that way you can figure it out. Come on! Why not? It's got a water pump, it's got cooling, it's got heating, it's got all the things. Why wouldn't you want to live on the road? It's got it all. Alright, there's the pitch, basically. The tires generate electricity, by the way. Just doing it right as I went by. Yeah. So does the frame. So does the trailer frame. Does that trailer have batteries? No. For the back, no. The tires don't generate electricity either. But they are still spring tensioned. Sorry. Vacuum spring tension! I'm sure people laugh. I'm laughing a little myself, if I'm honest. Why wouldn't they generate that? Because I have to have leads for that. From the trailer over to my e-bike. I want it. By the way, that trailer, handy dandy, multiple redundant little connector. Just in case. Which, by the way, this is not a standard little trailer hitch. This has a back and forth, up and down, you know, with the circle thing that I talked about. And then it can... Oh. Yeah, it's more weighted with multiple points. So it's like it goes from the front and it has multiple point connections to that rear where it's actually connected. It goes side to side, up and down, and it can tilt, you know, pivot at another point in front. So that way it's a lot less likely to tip, which is a good thing, I think. And it allows for you to rotate side to side and still be able to put power to the ground and turn with it. We'll also be able to go over bumps and so on. How does that work? So, you remember the Atkins cycle with the little arm thingies? Circle. Pivot. Circle. Bearing. Connecting triangle, crossed little arch beam, and then little triangle points. So it's like, those are straight, and then little cross arch beams that round into the center. So it's like, think triangle, and then a triangle, but that one's more round, and this one's more straight. Then you have the hitch, little ball joint. It's like this one's like standard, it goes up and down, side to side, is, you know, axle. You're going from side to side through the axle. The axle is connected, then that allows for it to rotate up and down. Same thing with that. Goes in, goes side to side, but you don't really want a lot of side to side, so that one has less side to side. But it does allow for you to pivot. Instead, this one has a bigger hole at the top and the front. That way you can tilt more. It says there's holes. You don't know about holes? I know about holes. Oh, that's good. Alright, so let me show you about these holes that you apparently might not know about. Remember ball joints? Like U-joints? You know, like ball joint, you know, socket? Remember there's a plate, circle thing? It's a ball, tilts up and down, dynamic, goes in and out, socket, up and down, rotates. So fluid, tilts quite a bit. This one more side to side, that one less side to side, lots of tilt though. Up and down, but not too much up and down. It's just geometry. There's suspension as a result, but then it's loaded suspension to the frame, but then it has a shock because sudden movement, fluid. And then the trailer hitch, which of course that's another version of the same kind of thing for the frame. Frame, same thing. From this point. Why would you? Because that's a lot of movement. You're right. You'd want that. Hey, we got someone. Smart person. They ride bikes probably. Yes, you'd want that. As it undulates and everything, you move it side to side. It has more of its weight pressed upon the entirety of both wheels. It allows for consistent traction both ways as it tilts and everything else. Of course, it will eventually tilt completely, but it's a lot safer now. Yeah. 4 wheels instead of 2. That's a good thing. You're going to want that. Especially the size of that. Exactly. I'm a big boy. It's a big boy! Anyways, because multiple pivot angles, a little smoother on the ride. There's a rear, no, it's just a singular. But I do have a frame over here that might be something border style for 2 people. With a side saddle that has its own electric motor that it can absolutely use with a battery in your throttle with connectors. 2 of them, left and right, you can use both. And it can go together with this frame that has the rear. This one that's single does not have that. Deal with it. That is a $3,000 option. You have to deal with that. What, for the side saddles? Yeah, but not the frame. The frame is actually $22. Nah. Wait, what? It's $3,000 too. Well, yeah. It's more. You have to deal with that. Yeah, I know. Sounds cheap. It's still cheap. You're getting the whole fucking thing. Anyways, moving on to Ed is 3 and 3. Those are not 1,000. They are not 100,000. They are 50,000 kilowatt hours. That's right. Split the difference. Each side saddle. They're not really saddles. People sit there, but 2 people can sit in that. You can split. And they're pretty big. We're talking full adults. But if you want the whole, I want to lay back and do nothing, well, guess what? You can do that too. So 2, so you can have fucking 4, and then 1 in the rear. That is correct. 6 total. Okay. That one is a recumbent for the rear one. You don't have any forward ones? Nope. No, that makes sense. Yeah. There's windshields galore for the recumbent and the, whatever the fuck those are called. So, Really? I just don't care. I remembered back in the day, it's been told to me, I just don't remember right now. I don't care. There's that. 2-seater fucking side pods, basically. With windshields, and they have fucking AC. If you want them, with fucking, the speaker boom booms. They have seatbelts. They, yes indeed, have the thing that goes, apparently they don't want me to say airbags. Why am you, shut up, don't do that. He's stopping me from actually saying what I want to say. Anyways, so they have airbags. You can see two people, one in front of another. Not side. They got all the accoutrements of cars. So there's that. There's a windshield. You have seatbelts, but you don't really have to use them. I mean, it's still like, I know. Let's say, so they have their own individual wheel, one in the center. 2 wheels, yes. Not 3, they have 2 wheels. There's suspension though. But you have one in the front and one in the rear, so they have electric motors. Yes, they do, yeah. That's right, yeah. What am I doing again here? I have a fucking 250 foot-pound torque behemoth and lots of fucking, oh my god, I have no way of doing the gearies. I have all this electric motors. This trailer weighs practically nothing. Yeah. You ever say how much those batteries weigh? They're about 10 pounds for 50,000 kilowatts. Okay. Really? Yeah, well, I mean, that's maxed out. Let's go a little easier on that. Yeah. 50 pounds. No, fuck that. There's no way. Get him over. 13 and a half for 50,000 kilowatt hours. So, it'd be about 20 pounds for 100,000. It's not, really, but you know, scaling cube law theory stuff happens to work out that way. Anyways. Yeah, I know, right? Electrostatic, electromagnetic. Yep. Each wheel. No, I'm gearing. No, there's just. But it works. Works well enough. For me. I have 6 people I can haul around into my trailer, which is pretty decently sized for that. Yeah, okay. Right, it has a decent... look at the hangers. Oh. I could put more people above my hammocky thing. It's that. No, but it should come with it regardless, and it is, so you discover it, but whatever. That works! Thank you! Appreciate that. So, it's 3,000, the 4K, 6,000, so 3,000 for each of those pods? Okay. For the frame, 3,000. 1K for that. Transmission, 1,200. Batteries, 1,200 or something like that. You get the picture. Yeah, so it's like 6, 9, 1,000, 10, 12, 2. I'm tired, yeah. 1,500 to 2. And you have to have the trailer hitch. No, it comes with the trailer, so it's 2,500. Okay? Alright. So, 12, 2, 15, 14, 7. So 14, 7. Then you have 2,500. So let's just get out the... I have a phone here. Let's just do this. So I'm trying to do it in my fucking head. So, 14, 700 plus 2,500 plus the bike in the trailer. Yeah, right. What was that again? I just said it. Damn it. What was it again? Why are you blocking me? Because you're tired now. I'm gonna go to bed. Stop doing this. $2,500 again. So $5,000. Right. So, under $20,000, you have a house, a smaller vehicle with trunk space, and the ability to, like a big old SUV, carry 6. You, your wife, and kids, all of it together. All across the country. Good old under 20 grand. That's fucking... Yeah, the torque helps out. You know that torque goes way up with those motors. Every fucking time. Yeah, I mean, that trailer... What's its actual max speed if you didn't have anything but the trailer? Its full distance is 1,200 miles. It can go at that, up to that distance, okay? At this speed, which is going to be, because apparently you want me, what am I, a showman? Fuck off. 140 miles an hour. Deal with it, you fuck! Stop trying to fucking make me tired and be a showman for you, little bitch. Guess what? The price went up for the fucking bike. Yeah, I don't give a fuck. You're gonna fuck around with me like that. Yeah, it's gonna go up. Alright. There you go. 19,700 without taxes. So that's probably about 25,000. Yeah. Close to, anyways. Yeah. So, there you go. Well, that's good. Yeah, nice, right? 250 foot-pounds? Yeah, it doesn't seem like a lot, but then you have... Well, let's see here. That's... 140 miles an hour for 1,200 miles. What's your torque now, motherfucker? Alright, fine. So I run this electric motor way harder now. 250 foot-pounds, my ass! I'm probably getting like 700 to 1,000. And then I have pods, because I have a trailer. Well, yeah, that's true. Alright, let's do that. I mean, do blah, blah, blah. 500 foot-pounds each of them. 1,000 then. Eh? What is this? You think I only have a stator? Fuck this. I'm gonna put an actual generator on this fucker. I didn't even have one before because I have a fucking waste heat generator and a basic bitch stator. Like, you know, like that's what they call an alternator for a scooter. So it's like, whatever, fuck it. Let's do an actual generator because you're annoying me. Let's get a 1,200 watt Fuck that shit. What, are you kidding me? I can do better than that. Let me see that. What is this? What is this? What is this? What is this? This is all you can do? Let me get out my metamaterials and my fucking PCB boards. Alright, we need multiple little tiny iron nitrate magnets arranged in between. There's some coils, spinny disc PCB. The central axle. That's the contact. Multiple stacks of this. Here's an axle with an axle tube. Now I have more generation. There's some air holes, I suppose. Why not? Let's just make this bigger and better. Fuck this bullshit. I think I'm not gonna fucking do it. Layer this fucking. This is a plate of iron. This smaller to bigger. Alright, so there's a bunch of smaller, like square, like circle things. It's square cubes, yes. Cube, rectangle, and circles with rods. And there's some donuts. And some balls. I get it. It's gonna look like a dick in some spots, because remember the whole electrostatic kinetic thing? Might as well use that. Kinetic gets turned into direct electricity. Direct conversion, very high efficiencies. This is like, well, if I can reverse the process, it's just kinetic. Well, I can now make electricity, so fuck it. Alright, so now, the same size as the stator. I am now making 100 kilowatt hours at, what is this RPM again? 300 RPM. This is not the size of the original stator. Of course, this is big boy stuff. I'm not weird and lame. I'm gonna do good big boy things. Look at the size of my wing here, my generator wing. Alright, guess what the size is? It's a 2-liter bottle of soda. 2-liter bottle of soda. Fucking bullshit. Don't do this. It's like weird. It's gonna look odd. Yes, you're right. Okay. Let's figure out a proper size for this then. Finally got you to tell everyone size can be odd if it's too damn big, bitch. Alright, there you go. So we're going to look at this little spin move here. What is this? Oh, what is that? What's the size of this thing? So, it's got it off the front. It's got it. Anybody got a guess? Anybody got a guess yet? Anybody? No? Yeah, you guys all suck. It's a Jiffy-sized peanut butter. Sorry, not Jiffy, but it's a large-sized peanut butter freaking jar thing. That's what it would be. Say the thing. 5 inches by 3 inches. 5 inches height, 3 inches diameter. It's a generator. So it should be somewhat decently sized. Deal with it. So, what's your actual kilowatt hours? You're gonna, oh my god, I don't want to know actually somewhat. It is 10,000 kilowatt hours every 1 minute. When at 1,000 RPMs. So, do that calculation, I guess. Thanks. Kilowatt hour for a minute? Yeah, just do it. You can divide by 60, can't you? You have a fucking calculator, I'm sure. Anyways, you get that for fucking free, by the way. Comes as standard with your fucking engine, mate. There you go. I just fucking. I just need more time to. What is this anymore? Yeah, I don't know. But here we go. Oh, you need your muffler. That's right. Sorry. That's more like it. That's probably closer to what that would really sound like. So, do you need 10,000 kilowatts? Jesus shit. Wow. Why would you need that? In a minute, by the way, for 1,000 RPM here. Okay. Jeez. Just do that. Fuck off. Oh, I know, right? Let me just run my engine with 30-gallon gas tank bullshit. It's not like I have fucking, like, oh, I don't know, windmills and freaking solar panels. So, you should talk about the solar panels again. Oh, yeah, so humidity differences creates, there's material, hydrogen, and steam thingy-majigs, because that. Turbine. Ah, shit. Heat differences, electricity, turny, electricity, generator, electricity. There's so much electricity. How many electricities? All the electricities. Remember Benny Benassi? Electricity. Anyways. So, done with that. Finally, right? What about the solar panel thing? Right. So, utilizing the, layered, mirrored things and Lindsay things, like Lawrence Lynn's plastic stuff. It's a mirror, it's a collective from larger, what is this, it can only work with this wavelength. So, you should destroy all of these others and constructively turns them into, by converting, like transformer conversion, into correct, by using Lemke principle laws of quantum superposition stuff. And light and so on, you get it? All the wavelengths, as best I can. Of course, there's conversion losses, obviously. But they're pretty high likely. To turn into the right wavelength. What do you know? It's cold anyways. It's true. Because, there's a layer up here, there, insulate, air, and so on. Air goes through, cools off. What do you know? There's boiling because, creation of hydrogen. Hey, you were there. All right, thank you. Bubbling, boiling away, air move, oxygen, hydrogens, vibration, material, electricity, charge differences, humidity, heat, pressure, convection, spinny, turbine, heat differences again, Stirling, humidity, electricity, recombined water, gravity battery, turbine, more electricity, potentiating the effect through gravitation, and insanely high degrees of efficiency for conversion of H2O to HOO. By the way, because surface area, heat difference, humidity, you get that collection of all this together. This is dehumidifier, goopy bullshit, goes in, collects steam, recombine, very good at destroying bacteria, so on. All of a sudden I get this potentiation, buoyancy, go up, had to travel farther down than where I started. Increased degree of electricity gained, potentiation, heat, buoyancy, convection, pressure differences. Like the prop design, spins, bigger spin, larger prop, all that. Potentiation, like gears, like torque. Of course there's laws. It doesn't matter, I got more than I put it in. I still charge batteries, by the way. So I'm making yes, no, that's how efficient it is. Cool, great, yay, alright. But you need that 30-gallon gas tank and a fucking generator that can do 10,000 kilowatt hours every minute at 1,000 RPM. You need it for some reason. But that's fucking 500,000 kilowatt hours. Yep, in your trailer. Fucking hell. Alright, so we're of the knowledge now at this point, right? Yes. Is this you are wrong about this and I couldn't do that? It's a standard, it's 2,500. For that trailer? Man, I'd fucking pay you out the ass for that. Yeah, well, you know what? Pay me now. Make it so I can make it and manufacture it. I'm sure you get a lot of money. Eh? No business models? Fuck you. I definitely do. And they'll be successful. Yeah! Anyways, there you go. There's that. Cool stuff. It's not that cool, right? No, it's insanely cool. What are you kidding me? I have a stable fucking... I can still tilt. Guess what? Yeah, I never talked about it, but those little pods, they'll tilt. They have camera tilt too, and they actually steer together. Same thing with the ones in the front and the ones in the rear. The trailer. To help you steer. It has the gyroscopic accelerator, blah 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 connector thing. Yeah, you get it. Mechanical. Yeah. As well, of course. Redundancies. Look at this. Are you sure you don't want to buy the trailer? It's only $2,500. Are you sure you don't want to buy the bike frame? It's only $1,000. Are you sure you don't want to buy it? You sure you don't want to... $20K. You sure? going to sell a lot of fucking things. Shook it. Suck it. The family's been owned. I guess that's what you said. That's true. They have. They thought they'd never work. It's not good. And you couldn't possibly through any of your processes, manufacturing, any of it. You, in every way, destroyed every bit of everything they ever claimed could not be done. You can clearly do everything of that and more. All you need is the capital and people. What do you know? And some marketing and oh my God, you could be absolutely multimillionaire, if not billionaire. Suck it! Yeah, you're right. Thanks. I agree. I do. So, that's one. One. I still have the turbines. I still have the jet engine. I still have the engines that I've also produced. I still have all these. I talked about this, but there's geometry for the plates, for like the in and out. So like top and bottom rotary engine. And it has the moon gear. Well, that helps it make it a lot easier to make those plates work and like timings work. But it's like not perfectly balanced because of the moon gear. But it's like, whatever. Usually is what that ended up being. But, okay, so I have 3. So let's do the... geometries are a lot harder. So if you don't know about it, it's like, So I'm still working on it. But I gave up a long time ago. It's just like, whatever, who gives a shit? Like this 12-cylinder, I could just cast it and put this on. I have the rocket and then just rotating the fucking stupid exhaust thing. Why have valves like that? Fuck it. Make it easy. Right into that. That's, well, the turbine coupler? Yeah, pretty much. Zin turbine with coupler. Torque converter coupler. AC generator over here. Hey. Sealed system, by the way. Cooling, all that. With the, motors, kinetic in this instance, we're going to go the kinetic accelerator engine electric motor variants, along with the, directionality tube thing, with the balls and everything in this instance. So it goes up and down and forward and backwards. So it could fly. Well, yeah, maybe. You know it could. Go away. I'm not letting it do that. Just to make it way more efficient. For the given energy captured into input of doing forward. Why wouldn't you do more than that? Because it's not a spacecraft. Stop trying to make me make airplanes. Oh my gosh. Look at this. Let me just go make a fucking kinetic accelerator engine. What's over there? Who's this? Slant. Inertial accelerator engine. Thank you. Anyways. We're going to go with... I don't really want, in any way, for you to go flying in any of your vehicles, except for this. This is a personal flying vehicle. It is not a motorcycle. It is a scooter. It's a 6-cylinder version. It has this similar stuff that goes on. It goes burr, you go up, you do the things. There's the potentiation with the heats and the spins of stuffs and so on. What do you know? It goes burr real well. Doesn't have a trailer. Whee! That's 20,000, by the way, by itself. If you know anything about physics and shit, Well, if you ever looked at any of my other stuff, you understand why that works, will work, do that, and all the rest. And also, it's going to be $20,000. $20,000. It's a personal flying vehicle. They have you pay $200,000 for one of these fuckers. Deal with it. I'm cheap. And better in all aspects. Suck it. Have fun. By the way, there's always safety features. So if you accelerate too high, meaning you do that thing where you go too high of an altitude too quickly, and you pass out, guess what? It starts to bring you back down slowly and bring you to the nearest airport or wherever. But it keeps you in the air and keeps you strapped on. If you wake up and you go somewhere else, it'll no longer have the autopilot be taking all control over. It can do G-force turns that will kill you. I have safety features so you cannot do that. Don't do that. Please don't do this. They can take these safety features off. Gunk. That's a lot harder to do now. Oh, thanks. Yeah, it's probably necessary. Yeah. Alright. I don't want the safety features. You can do a maximum of 15 G's tops with the safety feature. Although there's timing things with that one. Yeah, was it within 1 to 10, maybe 15 milliseconds at most? It's a car crash. That is indeed a car crash. You see what I mean? Oh, it goes up to 15. Why are you trying to do more than a car crash? What are you doing over there? What is this, 3? 9? Average? Fuck off. You're not doing 9. Let me see that. 5. You hit 5. And you saw a 5 as a 9. That's what that would be. Don't do more. In fact, 5 is deadly in its own right. Don't do that. Jeez. That's dangerous. Anyways, moving on. 20K. Fork it up. Early other better models is $100,000, all top of the line model. Guess what? It comes with a attached multi-functional suit, effectively. It's a suit, and it attaches to the thing. It's a bigger, you got a little bit of a ability to go into space. How much of an ability? Well, how long do you want to be in the suit for? And how much fuel did you give it? Do you know anything about orbitals or anything? Because you can be in space forever. You're going to die in that suit and everything, but it doesn't mean that, technically speaking, you aren't also in space, like I said. Or, you do a little more reasonable, or you know a thing or two, you can theoretically go to the moon and back. It would be one hell of a ride, I'll tell you that much. Probably shit and piss your shit for a while, although you do have 1G acceleration all the way up to basically the near orbit of the moon, and then you have to slingshot, because its weight relative to you as a kind of motorcycle-sized person on top of a motorcycle, all that is smooth. So there's that. And also you're going to have to burn some fuel to slow the fuck down and go. And please don't enter wrong. I hate these things. Like, let me enter fucking 25G. Get the hell out of here. This can easily slow you down to 1G. You just enter slowly. You can go straight vertical, land anywhere you want. Why are you doing this incorrectly? Why are you trying to... What are you doing? No! Anyways, but that's a thing that you can do with this. I wouldn't, maybe go that far with it. I mean, you're hitting the limits for what it's worth. I usually glide in for what it's worth. Again, I don't go just straight vertical. It's a lot of extra weight. Yeah, you give yourself some glide. But you can do it. If you want to go super balls to the wall, you can do it. And you can land. Super simple. Now you're no longer going to the limit. Although you're pretty close. You have less than a gallon fuel. So there's that. What was the balls to the wall? You have exactly 1 fluid ounce left of fuel. That's if you do it at the right time and all the rest of that. Yay! Is it really? This is terrifying. Are you kidding? Have fun with that one. I would never do it. I could do that all year round. I have less than a gallon, a little less than that at its closest and all that. So, there's, it works way easier. But it's $100,000. Really? $100,000 to get a min is too expensive. Okay. I don't have that. Okay, well, that's fair, though. But for the low price of $25,000, you can pick up every part of the kit and build it yourself. You don't get the spacesuit, though. But it'll do that. There's a caveat here, and I know it. Oh, it's pieced over fucking years. You're a dick. I'm a dick. It's $25,000. You can go to the moon. Oh, I'm gonna have to wait 5 years to get all my pieces. Boo-hoo. Go buy the fucking suit somewhere else, motherfucker. Well, for me, at a later time, truthfully. Really? Yeah, because if you get all the pieces, once you have that, the suit is unlocked. That's right. Okay, so the suit's unlocked. Okay. For how much? Good old... They want me to sell it for $50. I don't really want to sell it for $50. But I understand why they want me to sell it for $50. Considering the cost of manufacturing of the damn thing, I should probably sell it for $50. But it's for you! In several pieces, over the course of 1 year. You have to buy a couple of these nice little 3D printers and all the rest of it, or you can buy the plain old suit all together at once. $50. You can buy all this all told. It'll take you a year though. And then you'll have a suit in about 2 months. Now you're starting to understand why this is $50,000, even with all the cheap shit I do. Alright. For a low price of $20,000, And after 2 months, after waiting for 5 years, which by the way, you should probably be doing some amount of astronaut training in this time, please. Just hoping anyone, not saying anyone, I'm just gonna get them, fucking hate them just a little. Please, please, of course not. Alright, anyways, moving on. Alright. Now you know how to make all of it. You have these wonderful 3D printers. All these things put together. You got all this stuff. For $20,000? You know what you got out of that? Practically a replicator. You can build one. And once you go across the moon one single time and land over the correct distance, meaning you don't do it showboating style, you will unlock all of, that's correct, the instructions to make a actual real replicator down to, that's right, quark levels of replication. It's going to take you about 2 years and 3.5 months. But you can do it now, and that's if you did it perfectly, which I really doubt that you will do, so it will most likely be about 5 years. So, after 5 years, another 5 years, you add on the other year for spacesuit and the months and everything. And so you all told, let's do a 12-year thing. And 13, fuck it, 13 years. You will be able to have a replicator and go to the moon anytime you want. Yeah. But it's less than 2 decades. Woohoo! That's a bargain. And it's only for the low, low price of, wait for it, $45,000 plus taxes. And however much you need for fuel and all the rest of that. Hate this. Oh, it's okay. You'll get there. No worries. Don't stress. You'll live for another 13 years. The Earth and world and geopolitics and all the rest of it aren't having any issues whatsoever. And when did this happen? When I got the... Oh, good question. When did that happen? But you could have it. If only you wanted to try and work with me just a small, tiny amount. And show up and say that you're doing that, you bitch. Ah. Fucking hate these fuckers. Anyways, there you go. That is the whole thing there, yes. The creative ideas in process. This is what I have named this. Recording 4 hours, 2 fucking a.m., 16 minutes into it. Fuck. I have group therapy tomorrow. Don't wake up at like fucking 8 a.m. We got less than 4 hours. This is bullshit. Let's go to bed. You guys kept me awake for this? To record this for you? Whatever. Jerks. We didn't hear. Oh, fuck off. I didn't hear none of that. God damn it. Alright. Hopefully you now understand why it is that I talk about this. Because it's like, hey, that's my flying design. Currently, that's my personal flying vehicle. Yes, is it an aircraft? It's too small. Is it a spacecraft? It's way too small, in every way. So you don't have to do any of the shiny paperwork crap. You can just go anytime you want. Guess what? Turbines don't have CC definitions for legalities. Well, that's true. You have the 6-cylinder though. Well, I guess I just have to have a motorcycle license. But it's not that, is it? No. Move on. Is there multiple different versions to that? You telling me I shall let you go to space? No licenses? No training? No insurance? Okay, sure. Free spirit, open market, anarchy for the win. Let's go. Have fun. I just need close to $50,000. Come on, Mom, Dad. I need to be able to manufacture everything and all the rest of that. Let's do that instead. Let's get there. How about that? How about that? How about we get there first, huh? You hear the venom? Straight poison coming out? But, yeah, why wouldn't I want to take a little bit? Why? Because it manufactures it really hard. You know that. It's 100,000 all the time after that. Not many people fucking buying this. Oh, I shouldn't any way, shape, or form. Okay. Oh, shut up, man. I want to go to bed. Stop excusing yourself and your shit. Oh, he puked on my bed. Thanks, Phaser. You're not a nice dog sometimes. Such a shitty fucking piece of shit sometimes. He's the piece of shit. Oh, look at you. The dog totally understands everything I'm saying, right? Do you feel personally attacked that I called my dog a piece of shit? No, I'm just trying to fucking make people hate you. Yeah, I know. Everybody knows. Who wouldn't know? Just clean these too. Oh, is he puking? I don't know. I cleaned his bowl, his water, and all that. Probably just has like hair in his fucking throat because of the water bowl. I've been hair in it, shedding and all that. Anyways, that, hopefully, you fucking realize I'm trying to go to bed. So this is delaying me to going to damn bed. And these are the hopes and dreams of a person who has enough ambition and knowledge and wants to do the thing and all the rest of it. It has these issues. You sure you can't work with me just a little? I missed the switch. Boom! Suck it! I hit that fucking so good. What? She's a switch for you, submissive to you, terrible for everyone else. Yeah, that's nice. I prefer that. I don't want anyone else fucking taking any of mine. That's how that works. You wouldn't say that in front of people? Yeah, I would. Why? I'm recording it and this is gonna go on fucking my YouTube. I wouldn't fucking stop myself. Granted, I mean, you gotta get to know the person, I'm sure, but still. Anyways. I'm gonna